Yeah, but
I'm aware it might not.
I try to avoid the let's put every presentation on the same computer. It's more hassle than switching a cable.
That is true, but it's kind of, it's there and you want to see if you can make it work. Very nice actually, thank you.
You like living on the edge.
Which color table did you?
Black table.
I didn't even know what coral was. Well, what type of color is coral?
Coral.
The colour on the
Pinky thing.
program there, like that pinky orange.
This?
Pinky orange, like coral reef color.
Yeah, that was definitely not the color
No, I
color
know,
on
like
the.
they all had like there was turquoise and there was turquoise and there was turquoise and it was like, oh right, okay.
Just so you know, I've got about that much to go through it quite quickly before then I introduce you in your session. So just just so you're aware, then I'll introduce you, then you can introduce each of you individually. Yeah, good. So you know what to expect.
What time do we finish?
You start at 10 and finish at 11:45.
Okay.
So if you want to get, but if you're going to,
I do want to get a discussion at the end. We always, this panel things always end up people presenting and then 2 questions, no discussion.
Are you going to save all the questions? If not, you're going to let each people present and then, or and then
So I have 3 questions and then I'll open up.
Brilliant. Good. So there's enough chairs and stuff. Oh, the mics as well.
There aren't enough chairs.
1, 2, 3, 4.
Okay.
Yeah.
We put it.
Yeah, we'll bring it over. And probably fit you with the lapel mic.
Okay.
So you can be a little bit more free. There's one handheld for the. I think there'll be one handheld in the space for. For Q&A from the audience.
Cool.
What Mike did, because if you're on the lapel mic, you can still talk and actually run and hand it, or we've got runners who can do that for you. So it's up to you whether you want to have control of the mic and actually move around the space yourself, whether you want to stay here.
I'll stay here.
Okay. So either I'll do it to a runner or go to me hands. Okay. That's all right. It's just Mike to run around.
No, Mike like.
Yeah.
He wants to
We were too slow for him. He's like, no. So
that is true.
Hey.
It's usually people start talking and they go like, what?
Yeah, exactly. So it's.
When are you going to do some TV?
I just shot some stuff for BBC Code.
Video but they gave me the space.
They shoot like a year in advance. So that's good.
Worked.
Yeah, well, yeah. It'll be. There's always. It's more difficult than the amount of conversations you have when I get the projects going.
Sorry, we haven't met properly. I'm Karen.
Hi.
Hello, nice to meet you.
Nice to meet you. But we've emailed, so.
We have emailed. I know it's really strange saying hello to people. And I've emailed them a lot and just chatted, and I've talked to some people on Skype, and it's like, oh yeah, you kind of look like I saw you in the background in that pixelated.
It's a much better image from Skype than from nothing.
Yes. Do you were here yesterday as well, weren't you?
Yeah, but I didn't. I was a bit sick over the last couple of days, so I stayed a bit in the hotel doing some emailing.
All right. Well done. If I'm on the remote, can we try it with the remote? Of course.
We'll go back to the beginning just to see.
Remote. Ding, 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 ding. And
You have to click it to play, so you need to.
can I click from here?
No, that's just forwards and backwards.
Okay, and what's these fellas?
That is start show and that is black
Will
screen.
that do it?
And if you just click next,
So
Daniel?
when
Did you try clicking next? Now it starts playing, no? Now it starts.
no, it's gone one on top of the other. Yeah, so we have to. So what I'll do.
So when we get to that slide, I
I'll
need
just
to.
ask you to click on and you just click the mouse.
Okay. Can I click anywhere, or do I have to click on play?
Play button.
Okay.
Okay, and sound do we have?
We will do. It's down at the moment. But if it works here, it will work through the plastic.
Okay.
Where's
South
the
Africa.
rest of our panel?
The guys in South Africa.
Ah,
doing,
okay.
Do you have a camera as well?
Yeah. So can we see your
Yeah,
So
like this.
we're going to want to show this
Mm-hmm.
At what point do you need the camera? Will it be
after the 3 presentations.
and then
That's
the
going to
camera?
be the first question.
Yes.
After their 3 presentations, I want to go to my last slide,
Okay.
back to the
You'll go back to your last slide.
yeah,
And then
and leave it. So it's if you
because
see,
once we put the camera on, you won't have any. This is different channel, so you won't have
yeah,
any.
yeah. So I want to go to back to my slide,
Yeah.
present the question about the tool,
Okay.
and then we're going to each person is going to. And will we see what we see on the camera here?
No.
No. So it will be only on the screen.
Yes.
So okay. So I'll have to stand here like this.
Well, no, the camera's got a screen. A few
Oh
of
yeah.
us.
Okay. Technology.
Too early, man. Didn't even think of it. Okay, yeah. So what I want you to do is really talk about the details, like one detail. Why?
Okay.
Kind of what work did you
Yeah.
you know?
Yeah, this is the
detail.
whole part.
Yeah, and it's on Instructables, isn't it?
Thingiverse.
Thingiverse, even better. Yeah. so
Well,
that's
considering the whole MakerBot discussion, open source, closed
you know, I
source.
went to visit him.
Yeah?
Yeah,
When?
yeah. Free. Hmm? Shall I do it?
Recently.
Just now
Okay.
in Brooklyn.
How was he?
Amazing.
Yeah?
He's not allowed to do anything with 3D printing for two. Oh, brilliant. So we're going like,
He's now running this, what is it? The lab?
yeah. Yeah, he's got a new lab, Wicked Tools or something like that. Is it Wicked Tools? He told me 2 things. One is
Sorry, who's first?
me.
You. So you do yours,
Yeah.
and then we'll switch, etc.
Well, Brendan is first.
Every
Do you
year.
have any slides?
No, no slides. I'll just be on the
Then they go back to your last slide,
Okay.
and then the camera.
Yeah.
I'm the last one, right?
You're the last one. So Kirsty, Greg. Have you guys seen the roller on the floor for tape?
Yeah.
The gas
So
gun.
expensive though.
Yeah, but you can make one.
Can make one.
I'm sure you can 3D print the
Sounds
the
like
bits.
just 2 rollers, no?
Yeah, you can make it. You know, have a good look.
Yeah.
Are you can you do CAD?
Sir?
Do you know someone who can do CAD? You can.
Tiny bit anyway.
Yeah, I don't think it's so sophisticated. It's just clever. Have you seen it?
No?
So you hold the gaffer tape on a kind of a spool,
This one will
and it sits on a plate that has a triangulation that collects the cables, and you run on the cable, and it lays the.
So it does multiple cables.
It does multiple cables as well. Yeah, it's great. So we'll do this. That will be the first slide.
I'm intrigued by the story.
So-
I met him like when he started. When we were,
Yeah, yeah. So he was in a garage in Brooklyn
Yeah.
with 4 kids.
that's where I met him.
Right. He's now bought that garage again. You
Yeah.
know, they moved. They got
Mhm.
70 people, 180. They sold.
Mm-hmm.
He bought back. He's back in the garage with 4 people.
Really?
Yeah. Playing around.
Did you see the Netflix documentary?
I heard about it. I heard he doesn't come out very well. He's probably unhappy.
No, but I
Should've
didn't know
get
what to
coffee.
expect. I was thinking it's like another happy 3D printing story.
No, no. But Yoav
It
is
was
in it.
quite-
Yoav Formlabs.
Yeah. Do you know him?
Yeah, yeah. He's a student.
Okay. Yeah, they came out a lot better.
He studied when I was
Yeah.
15.
It almost felt like the investors paid the documentary.
Yeah, they came out very well. And also they actually use design in the best way.
Mm.
Get some coffee.
And you lose one when you leave again. Yeah. Yeah. Did you? Okay. Ah, yeah, me too. Well, I knew two of them already, so that was quite okay. I never like it when you're like plopped in. Okay. Mhm. Okay. Ah. Yeah, it seems like they didn't do it randomly or something. I was next to Katie Bernal from Falmouth Autonomatic and Fee Scott. She gave a presentation yesterday. Ah, okay, me neither. But Daniel um, invited us both in Poland for a talk. When was she here? Oh, here, off to me. She does this, how can I say, like a directory of small manufacturing industries going from like one person in a shed to small factories and things like that that still produce, and then they make videos of them like to show what they do, their skills, their passions, and then list them all on a map. And now they're expanding. I think she's from Scotland, and now they're expanding to the rest of the UK. And they're doing, I believe, adding like 200 more small and large companies.
Compared to the others.
That's what I said. Like, yeah. Why do you ask like three people working with machines to bring hand stuff?
I'm going first, Kirsty second, you third, Dries fourth. Yes. Then I'm going to flash. I'm jumping right into there. I'm going to put an image of a flint. Okay. That's the tip, and all three of you have brought tips. Yeah. And we're going to use this to just. The thing that you tweak or the thing that makes it work. Yeah. Oh, it's 10% work.
Can I give you a mic? On your in your pocket or on your belt?
Yeah, you're sitting here. I'm probably standing. Get.
Presenting as well.
Yeah, he's. Me first, Kirsty, Greg. Is that all right? Or
Yeah.
is that a good place?
Sorry, yeah, that's good. Yeah. Just try and wrap some of this up.
Okay. Yeah. Stuff it in the
Just tuck it
pockets.
in, yeah, and go for it. Let's just check. Yeah, we're good. Alright.
Where do I turn it on?
It's on, I'll do the
Where do I
volumes.
turn it off? If I want to swear?
It's a mute switch if you
Okay.
do want to swear. So it's on mute
Alright.
now. Just remember to switch it back, yeah?
Okay.
Yeah, me too, but somehow I forgot. Yeah. And I have a little UK back with like the UK version of this, and my oyster card and some plants. I forgot the whole pack.
It's almost the size of my scooter, Greg.
You can reverse the air pressure, you can actually.
Thank you. Right, so there is, you know the film thing? You'll be on it? Get
Oh,
to
yeah,
slide
yeah.
7, you have to click the film on.
There's only one, huh?
Yeah, and there's.
Is this yours?
Yeah, I'm going to take it away. And I'm not sure I'll show the whole film because it might take too long. So I might ask you to fast forward it to like 2/3, or I'll come and do it.
If you just say stop.
Yeah, so, yeah.
Okay.
Were you at the meal yesterday?
I was.
Well, I didn't see you guys. I came in a bit late.
I was going to say we didn't see you because me and Ben were both there, but we were both hidden away in dark booths.
Anyone want water?
Thanks.
Yeah. Lots of people, huh?
Yep.
Yeah.
I don't know.
Daniel, I'm
Hey.
going to sit on this one today.
Okay, because you've had enough. Yeah.
No, because I was in this room yesterday, and if we have to sum up, I better hear something that's
Okay.
not the main room. And if you're in there,
I'm not
doing
going to
this
sum
thing-
up mine.
I know, but I've spotted Mike's in there, so spreading us around.
Good. I heard it was awesome. I wasn't in. Is that your bat move?
Right, I'm coming down with something. I had to go.
Go in.
Bring on the Lemsip kind of feeling.
Lemsip is fictitious. You know that. A material person doesn't do anything.
Paracetamol. It's basically
Yeah.
paracetamol. Paracetamol does do something.
Yeah.
Yeah. But that's doing something.
That's
Placebo
doing
is a
exactly.
real thing.
It is. It's true.
So don't
It's
burst
true.
my placebo bubble.
But it's not material.
Unassembled sheets of this stuff. And he's standing on a nice shelf.
Yeah, I was thinking I was going to get one for my friend.
Have we got a few more minutes, or when are you starting?
In
At
about
quarter
30
past.
seconds.
30 seconds.
Oh yeah, it's 10 o'clock we were starting.
Yeah.
But my bit will take a minute or so. But
Yeah, yeah.
Yeah.
Okay.
You're
I'll
right.
be 1 minute. Yeah.
That's handy. I've made things do that.
Hello. How's that? Levels coming through. Brilliant. Hello, good morning, everybody. Welcome back. I hope you all had a good evening. Those of you who came to dinner, lovely to see you all. I hope the rest of you had a nice time catching up with friends and colleagues. I'd like to welcome you back to Makeshift. I can't give such an eloquent introduction to the whole programme as Rosie's yesterday, but just so you all know you're in the right place, at Makeshift we're exploring how advances in materials, processes and technologies are driving innovation in craft practice and how they are creating new opportunities for makers to contribute to innovation in other sectors including science, engineering, manufacturing and medicine. We're going to continue this conversation today with our third and final session on tools. That's going to be followed by a forward-gazing final keynote from Amar Machan and a final summary session with the hosts of each of our sessions from today and yesterday. You'll remember that our sessions are split between here in the long space and the in conversations with Anthony Story. So again, as yesterday, please feel free to move fluidly between the two spaces, sit at either end of the rows if you would feel like you're going to be moving between the spaces to try and catch as much content as you'd like. Reiterate the housekeeping rules again. We have open access to the building, so make sure you're wearing your badge. There's no fire alarm scheduled. If it goes off, please make your way down the central staircase, and our muster point is outside
the Emirates cable car. There's a coat rail at the back, but obviously this is a public space, so please be aware of security issues. There's no smoking or e-cigarettes allowed. Shops and restaurants around the O2 if you want to go to stretch your feet. There is Wi-Fi access working. Go to Rave Guest Network and just log on with your own personal details. That seems to be working pretty good. Twitter, please do keep on giving us your questions, your comments on hashtag #CCMakeshift and at @CC_innovation. You may have noticed actually by the coats there are 3 or 4 notice boards with questions pinned along. We should have flagged this up yesterday. There are cards there. We'd like you, in your spare time, not that there is much, but please do go and give us your thoughts, because we're interested to hear what you say. So they're just little nuggets for you to actually start collecting ideas around, which are going to be really useful for us to start collating some ideas after the event. There's a camera crew that's going to be around. There's a photographer. If you don't want to be captured for any reason, please let us know. And also, please do visit Makeshift Do, because there is a continuing experience to what we're doing here today. Open studios, go and see people who make. Their doors are being thrown open in London, outside London, for you to go and visit and get some real hands-on experience and query people about their practice. So, the third session, tools. What are the new tools and technologies, and how are they driving forward craft practice? Can we see examples at work? Welcome to our third and final session on tools. To introduce this session, I'm delighted to welcome Creative Director, Curator and Design Educator, Professor Daniel Charney. Daniel's exhibition, Power of Making, for the V&A and Crafts Council, as Rosie said yesterday, was their most visited free exhibition since 1950. In 2012, Daniel co-founded Fixperts, an international open design creative social platform. His latest projects include the Maker Library Network with the British Council, which is an open design mentoring platform that connects makers in South Africa and the UK. I could go on, but let's just say he's a most excellent international maker with a global mission. Daniel Charney.
Thank you. Morning. Is this working, this thing? Yeah, great. So thank you all for coming to this session. We have really, I think, a super interesting group of people talking about what they're doing today, but also in the context of their innovators hat on in relation to materials and the making that they do through the tools. I've opted to call this kind of introduction the ratchet moment, because I think with tools there is this point where you can't go back many times. Something clicks and we know it exists and you start using it. At the beginning it's brilliant. You're exploring it and you get into it and it starts becoming the way you do something maybe. And then maybe it starts limiting you because that's the way you're doing it. And then another ratchet moment comes along. And I think when we look at tools today, and there's 3 speakers that are completely involved in using their tools creatively, I would like to think about this dilemma of when does the tool enhance and when does it stop you from moving ahead. So we have Kirsty from Knitton, Greg from RoboFold, and Dries from Unfold, but they also all work under their own names, and they all are involved in other practices, and we'll talk about their work a bit later. But I wanted to kind of touch on a few points thinking about tools and where we are today and what is maybe worth thinking about this dependency or this independency. And I'm quite addicted to the whole Earth catalog again lately. I managed to bag a copy on eBay finally. It's quite big. And there are lots of things about the empowerment that tools give us, and quotes, and ads, and It's very much about this go out and do it yourself empowerment aspect of it. But it's also, I think, opening up the idea that you can change the tools and contribute to what tools are, not just accept them. And I'm reminded that I studied industrial design in the late 80s, and it was very technology focused, and technology was ahead of us in that way, that design was taught as a way of kind of trying to understand technology and what it can do for the industry. And as the years moved by, the focus became more on the user and society, which I'm very happy about, and this is something that I've seen and gone through myself. But every time that we were talking about design, it was really as a mediator between us and the environment. And one of the questions, I think, is our relationship and things like the concepts of Latour or Gourand that are describing the curtain of objects around us, or the way we mediate with the external world, the non-human aspects of the world, and do they become part of us? And there's this question, are tools an extension of our capabilities, of our body, or is it really the mind, extensions of what we are thinking about and what we can do? And anyone that's used stuff that they got used to, you sometimes forget you're holding the tool and you just get into it, and it becomes something that even if something goes wrong, you're able to kind of keep going and maybe even discover something. So this question about the relationship we have physically and mentally with our tools, I think you all have that to some extent on a daily basis. It would be nice to hear what you feel or think about it. And one of the things that we've done in the last few years is try to get makers, designers, engineers, or anyone that can make and solve problems through making to help people mediate their environment through improving little things and doing them quickly. There is a little presentation outside, but Fixperts is really very much about using design to create, or making, or craft, or fine art, whatever you call it, to make tools for living and change the way that people feel about how their confidence about doing things and making and using things. So I've brought one film which I'd like to show, which is a project, one of the Fixperts projects that it's happening in about 16 countries now. It's an open source, self kind of initiated thing. We get the films, we put them online. We kind of have guidelines of how to do it. It's an invitation, basically. It's not an organization. It's kind of a lot of enthusiasts and teachers and professionals. It's on very many levels. This was a project run in Johannesburg, where the students were really inspired by the tools they use in the workshop to solve the solution. And I thought it was a nice way of showing. So Sarisha doesn't have a tool that we all have and take for granted, which is kind of our hands. She has a less of a capacity with her hands. And how are they going to solve that and give her those capacities? We've seen a lot of these 3D printed prosthetics coming out around now. So is that a tool or is that not a tool? It's a question. I think it is, but it's also the fact that you can think, I can use it now. This extension is me or not. So we're going to jump ahead because I don't want to, the films are outside, but if we can jump ahead to, so they go through a making process. All the films show making, using tools, reminding people that, but if you can stop here, they came up with a kind of vice. So they were looking in the workshop at the tools they use for making, and they've made her a vice, or two little vices, one for holding a knife and one for leaning against a jar and using one hand. So they were inspired by the tools they're using to make. And they're really immersed in that environment. And I think it's a really fantastic way in which the fluidity of their solution came from their environment. You can't solve these kind of ideas are really hard to come by if you're not in the workshop. You're just sitting there trying to solve it. So I think we'll just jump ahead, but if you can just pause it. So that's the vice, and she's using this very natural thing that we lean on the counter anyway when we kind of prepare food. And she's able to lean and just open it now and make sandwiches for her siblings. So it's changed quite a lot of things. Is it going to jump? Oop. Right. This tool is refusing to work. What do we do? Maybe cut. Oh. So I'd like to also, so this is tools that are for maybe living, but they're tools that I've seen being developed in a community and the knowledge around them. These are 3 projects. In each case, it's someone who's engaged with a community that has a knowledge of making and using tools and intervened into their tools together with them, changing their practice and changing the community's practice through the tools and creating this new knowledge. And I think I just want, before we head into the presenters, just to think about the way that we use tools and the way that makers think about making things. And Vasari talks about these 3 ways of making, of adding, of subtracting, or of shaping. But what's happening today when the digital has kicked in? Can we still call them tools in the same sense? We're kind of bringing in all kinds of degrees of intervention and intelligence and lots of decisions that are being taken in advance that are now kicking in. Can we still call these tools? Do we need to differentiate them from machines? I mean, there was instruments in the middle, maybe mechanical, but and I think that to some extent that's the biggest question here: is the impact of the digitized world on your work and the tools. And are we gaining or losing from this interaction? So obviously, we try things out, and this aspect that being limited by the technology from breaking away from it, I think is a big issue today. People get into habits and they limit the scope of which they, on the other hand, they get very professional at a specific tool and achieve very interesting things. These are 3 examples of interesting projects that use digital in combined with a physical intervention. And I think when we're thinking about tools, that's kind of the key questions that I think are relevant, that when you choose which tool to use as a maker. So obviously what is being made, but how it's being made, what environment, what numbers, where is it being made, and who is making. But I think for me the most interesting question is who is it for, from a perspective of bringing in when you are making and the decisions that you take. And that brings us to the question of the relationship between makers and users, which we are seeing all kinds of new iterations and new opportunities now that are coming back to somewhere where we've definitely been before. You know, makers, users, manufacturers, it used to be the same person to some extent. And the relationship between maker and manufacturer, I think all of you are deeply involved in. So I won't talk a lot about that, but things are happening in this gap between them. This is something that, working on the permanent collection display for the Design Museum, we've introduced a new way of thinking about the relationship between designers, users, and manufacturers. You can see the first beginning of it in the Design Museum permanent collection. Hopefully that will be much more manifested, the kind of relationships around the user maker or the manufacturer and the user in the new Design Museum. And I'd like to introduce our speakers through this quote, again back to the Whole Earth Catalog, this level of making your own tools. And to do that, I'd like to kind of suggest that there are levels that relate to practice, to process, and to product. So our first speaker, Kirsty Emery, is a knitwear designer and maker, also a founder of a new company called Knitton, who has a shop, actually, manufacturing on site in Somerset House now. And she's going to talk about her practice, but also the way they are using, their practice is producing dependent on a tool that they've hacked and changed. After that, Gregory Epps, who's an inventor, engineer, and director of Robofold, but now also another company, Robots.io, multiple entrepreneur, I think it's called now. Before that, Shapes, and is also a teacher and really involved in the process. So inventing the tools and the elements that allow people to engage with the process. And finally, Dries Verbruggen from Unfold, who is also under the kind of artist, designer, inventor. I think we can put all these things aside and just see the direct relationship to the impact of the digital on producing new tools, new opportunities, and I'm hoping we can hear about that shift between maker and manufacturer again. Over to you, Kirsty. We're going to do the 3 talks in a row, and then I've got one question ready. So after that, we'll open up. I'm hoping we can have a conversation about our relationship with tools and innovation. Open up if that's possible. I know it's usually no time, but I think there might be. So while you're setting up, Knitton was founded by Ben Allen Jones, Hal Watts, and Kirsty, and joined by Greg Backer recently. And they, it's kind of the newest of the companies that we're going to see here. Greg has been working since 2008, more or less, as a company, and Dries since 2002. So we've got kind of a 5-6 year difference of engagement with the company and the digital tools.
My laptop seems to have died really helpfully right now.
All right.
I don't know if maybe it might be easier if one of the other guys go first once it starts itself.
Okay. Is there hope, or do you want to talk through with
I think there's hope.
Okay.
It's just taking a little while. It's rebooting itself.
Okay. Should we move on to you, Greg?
Sure.
Yeah.
It worked just before, perfectly.
So I think I'm going to fast forward to the introduction to Greg. And one of the interesting areas is the relationship between prototyping and production. That point where something gets good enough to be the thing. I think when you are working with tools, there are these moments when you choose to kind of use cruder tools to try something out quicker. You move into a more refined state. In the case of using robots, it's a bit different because you're programming and it's the coding that becomes the thing that is being tweaked alongside the physical.
Thanks, Daniel. Hi. Can everyone hear me?
It's all right, he'll fade it up. Just keep talking.
Okay. Now you can hear me. Now you can hear me.
Keep talking. It's like Skype. It picks up.
That one is in the middle. If you want to use that.
Oh, it is now. Good.
Okay,
Good.
great. Thanks, yeah. So I'm just going to take you through a little history of
the advent of automated machinery, I think it's quite useful to see how robotics has developed over time. Okay. Any better?
No.
I'll just let him run around. There's a guy up the back who's going to fix it. That sounds better. Yeah. Thanks. So I just want to give you a little background of the field of robotics, how it relates to automated machinery, and after that, just show you a little bit about the RoboFold process in a short video. So we'll try and keep it nice and quick. Okay, so as Daniel said, I run a company called RoboFold and recently started another company called Robots.io, which is providing robotic software. So the same software we developed for our own use, we now sell for other people to build their own processes. So I gave the talk a subtitle of instructions or machines in reference to the question of what is a tool. And the earliest example of an automated machine, let's say something that's slightly disconnected from the process itself, something that is using instructions to control the action. So this is the earliest example, 2,500 BC. And it's basically a vertical mill. So if you're into CNC machining, you would understand that this is a pretty simplistic device for machining in the vertical axis. This is the first automated CNC machine from 1942, and it's basically the same thing. It just mills vertically. You can move it around a bit to the left and the right, depending on the instructions you give it. But you can see that quite, I think, is a relatively simple idea of taking a tool, a spinning tool like a drill, and driving that downwards and then moving it left to right, forwards or backwards. You can create objects. But what's more relevant there is that very quickly after this, in 1959, the CAD project started at MIT. And we know now CAD as computer-aided design, it started as a project. It was named at that point. But the interesting part of it is the highlighted here in red is the long-term goal is automatic manufacture once the human-computer design team has established the features of a design. So for me, that's really interesting, that there is a direct link between the instructions and the machinery or the tools that are going to manufacture. This is the first example of that. They took a 2D drawing. This is a General Motors in around 1963. And they take a 2D drawing and they, from that, create a 3D drawing. But the 3D drawing itself generates the G code for the machine. This is the code that the CNC machine will read. So there's a direct link there between the designer's drawing and the object that's being made. Potentially that's something we've lost today. We imagine that these stages are discrete. You do a drawing, then you make a 3D model, and then you manufacture the part. But something we've all been talking about in this conference is that you need the intent, you need the expertise and the experience of how the thing is going to be made downstream in order to design upstream. And you can't really, without that implicit knowledge, you can't start on that journey of design to manufacture. Something that Daniel showed as well, Ivan Sullivan's Sketchpad, which also finished around 1963, which is a pretty amazing piece of work. He invented really the CAD software interface as we know it today. But what's interesting about the work is that he built in this idea of association. So here the pattern that is being arrayed on this lattice is associated to the lattice. So you basically you can change parts of this and everything else would update. So if you change the formation of the lattice, all of the pattern arrayed over it would have to update as well. So that's very interesting there, that not only do we have this connection from the design through to the manufacture, but if early on in the stage you update the design, then very later on the code for the machine itself will update itself. So you don't have to operate discretely at each stage. You can update just the first bit and everything else will change. And that's something that's really important in my work. So I just wanted to fast forward a little bit to where we are now. And I guess everyone's familiar with the Maker's book by Chris Anderson. But the subtitle, The New Industrial Revolution, I think is maybe not quite true in the sense that the first industrial revolution wasn't really a revolution. It was a very incremental change over a few hundred years of basically blokes in sheds tinkering with steam engines and lathes and things like that. So it was a very slow progress, very incremental change. And so right now we have the MakerBot as the sort of poster child of this maker movement, but it's not so revolutionary. This is the same machine that I showed from 1942. It's just a 3-axis mill. The only difference is the thing on the end of it is squirting out some plastic. So what we have, in fact, is sort of, this is almost $3,000, but you pay for the box, and it's just the extruder on the end, which costs about $40, which is the bit that's doing the actual production itself. So I don't think it's changed a lot, and I don't think it's as revolutionary as robots, which is my interest really in as a tool here. And the robots, I mean, this looks really advanced. It's a car factory. There's lots of robots working simultaneously, doing welding and things like that. But they've more closely replaced a human than these big specific machines. They're really much more all-purpose, and it's the software that is telling them what to do. So what I found in my own practice really is that the success of the robot is really down to how well it can replicate what you do as a human. And to that extent, what I mean is you hold a tool when you work, and you work with it, and you create an effect with it. And if you can replicate that well, you can get a much more subtle and refined output than you can with a 3-axis machine, which moves in Cartesian coordinates, and you have to work within its envelope. Whereas this, you work outside of the envelope, just like we do, and you can hold lots of different things in your robot hand. And also, robots begin to use sensors so that they can make decisions based on environmental aspects, the proximity to something, the pressure that the tool is exerting. So what's happening right now in the field of robotics is people are looking back at craft techniques, looking at etchings from the 17th century and working out what people are doing and trying to recreate that with robots, because there's a big jump from then until now, where we've been removing that craft, trying to automate it, trying to make dedicated machines that will just make the same thing again and again. But robots have managed to sort of leapfrog that, and they can actually do different things every time because the software is telling them what to do. And software is very easy to change, and they can become very subtle and very refined. So I think that's a great opportunity. So I'll just give a quick overview of the RoboFold process, just to give you some context of how that plays out in the technology that I've been developing. And again, this is all about the sort of data flow. So we start by hand folding in paper, but we end up with a physical artifact in metal, but there's a continuous flow throughout, which goes through the software, which is really important for us to be able to create very varied pieces with subtlety. So we fold paper. I think everyone's probably quite familiar with how to fold a piece of paper. You can actually fold along a curved line as well as a straight line, so that gives some great effects. It's very easy to do with a scalpel. You can just pick up a piece of thick paper and lightly score along the surface and fold into these interesting shapes. And it becomes an intuitive process, so it's very difficult, I think, to imagine these types of shapes. We can imagine soft, curvy shapes because we've been looking at them for 100,000 years, human bodies, parts of nature, but sheet material is more of an industrial material. We don't have the intuition, but we do have it in our hands, so we can learn very quickly in our hands how to create interesting shapes, and more than that, just to receive interesting shapes from the exploration process and start to choose how to use them. What we do with them then is to start to create digital versions of that paper, and then we can start to vary them. So in this example here, these are lots of panels used on a facade. There may be thousands of different panels here, and so each one can have a different fold angle, different fold curves, different orientation. But because we have this in software, we can extract the information for each individual panel, and then in the next stage we can send that to our software for cutting, which will generate the code for the cutting machine. So if I update the facade and vary the sort of angles and orientation of all these pieces, it will automatically update all of the drawings and therefore the code for cutting. And traditionally, if you wanted to make that level of variation, you need to do that by hand, or you don't do it. Maybe you modularize something and have 5 different versions, or you have every single piece exactly the same. And metal forming traditionally has, in the industrial setting, has required tooling. So a male and female mold, which is very expensive to make in the first place, but if you're making thousands of pieces, you can amortize the cost, so it becomes quite cheap. But you have the same piece every time. So because we're cutting with a computer-controlled machine, there isn't any extra cost to have it different every time. And the same thing occurs with the robotics. So this is our robotic simulation software we've developed. And here we're simulating the folding. So from the fold simulation that we create, that then drives the robots in the simulation. So it tells the robots where to move. And in the real world, the robots move and the material follows. So we have a kind of reverse process in the simulation world. And this is part of the simulation software, where we try and determine if the robot can actually reach all these different positions. So just like your own arm, there's certain positions you can't reach. So we have to make sure that the robot can do all these things. There's certain positions, if you do this with a robot, it gets very unhappy because it tries to spin lots of parts around at an infinitely fast speed. It can't do that, so it fails. So there's different things you can't reach. So we have to make sure all these things are valid, and this is a sort of interactive environment where you can see changes that you make to the work object or to the position of it affect how the robot operates. And you can end up with then a successful execution of the toolpath. And this is the panel we were looking at being formed. We have the same tools here that you can see holding the piece, which we'll discuss in the panel later. And this is the final output. So just a small part of that facade, but each piece here is slightly different. And it looks nice, I think. And that's kind of what got me into this in the first place, is you get really nice results, really beautiful aesthetic, but each piece can be different. And that is kind of the standard feature of this, that everything is different, and that's something I really like. So I'm just going to show you the forming of one panel before we finish. It's playing up there. So this is a panel from a large-scale work we did, a piece of sculpture for Zaha Hadid Architects, the Venice Biennale. And this is a panel that has been cut with a CNC machine. You can see on the underside there's a score line, the same way you'd score a piece of paper. And all the holes and everything are pre-cut in that. And then this forms in quite a short space of time. This is running at 2 times speed. So then that piece is formed, and then we just place another piece of metal on and we keep forming. So in very short space of time, and this is pretty much comparable to mass production speeds, but we have that craft element of being able to customize every piece. And this is the result, which is about 11 meters high. There's 488 unique pieces of aluminium sheet, which were formed and then transported to site and assembled. And here's a few pictures. So it's a really interesting aesthetic for exploring. And I urge you to grab a piece of paper and have a go.
Are you ready? Yeah. Cool. Thanks. Thank you, Greg.
Thank you.
Yeah, so while Kirsty is plugging in, can you show, I've asked each of the speakers to bring the tip of the tool that they work with. And so while Kirsty is plugging in, can you maybe show us what, that's not going to work now, is it, no, the camera? You can, that's so big enough.
Let me hold the screen. You keep talking. Do you want to hold it? Or
Yeah, I'll hold it, yeah. So the robot holds a tool in the same way that you hold a tool. And it just holds a tool in order to give it functionality. In this case, this is a vacuum gripper. So it's basically, it's holding a hand, and this is a very primitive hand, as you can imagine. It picks up flat sheet. So it's actually, it's not a very advanced tool in a way. It's actually very simplistic. But
I guess the detail of this, I mean, is this something that kind of can, where does it go wrong? The grip?
Yeah, it can. If you don't have enough air pressure, then you can't hold on hard enough to the piece of material and it can fall off. It's extremely simplistic. I mean, imagine how complex your hands are and how sophisticated they are. This is a very, very simple hand. But that means we have to put all the intelligence into the software to get it right. Yeah. And lots of trial and error as well.
Do you feel that as part of you when it's moving? Or is it like...
Well, yeah, because we'll fold everything by hand first. We'll fold in paper and we'll also fold in metal and feel what will happen. If I put this in a certain place, will it work or won't it? And that comes from the tactile feedback and knowing that something may be too springy or too difficult to fold or the bend is too tight. We'll know if this will slide off or pop off in a certain place. So
Right, thank you.
Yeah, thanks.
More questions I want to ask, but we're going to move to Nitin and Kirsty and her friendly computers that come back to life.
Hopefully. Yes. So, hi, I'm Kirsty. I'm from Nitin, as Daniel said. We do mass custom knitwear. So we are using existing industrial knitting machines, but we've recreated software so we can do completely custom items. If this works, somehow doesn't look like it's playing ball. Worked perfectly fine 10 minutes ago. There we are. Cool. So I'll show you a quick video to roughly explain what we do. Or at least attempt to. There we are. Oh, no, okay. It's not wanting to play this one, I don't think. We'll give it one more chance. Here we are. So I'm fortunate enough to be able to work with 3 engineers who are called Hal, Ben and Greg, who unfortunately aren't here today. But they provide me as a knitwear designer with the tools to be able to bring my traditional knowledge and craft skills up into the future. As you saw on the film, we are based in Somerset House and have hacked an existing knitting machine to create these new pieces. So a bit more about me and where I've come from with my skills is I'm trained as a textile designer originally from Chelsea College of Art, and then I went to the RCA where I studied women's wear knitwear. So I have a very long and now very deep understanding of knitwear, from the very basics right up to being able to put together large collections which seem much simpler than you at the beginning than you think halfway through. So through my education, I've started out with using very traditional knitting techniques, so hand knitting, which I learned as a child, although it is not something which all knitwear designers do learn or do know about, but I found it's really helped me understand the structure from a very basic starting position. On a very basic level, if I drop a stitch, I know exactly what's happened, how it's reacting, and where to go next to fix it, or if it even is fixable. Then through my education, I moved on to using a domestic machine, which is the rather interesting looking machine on the right-hand side. So these were very popular, which you could own in your house, just set up, in about the 80s. And there are still a lot of them kicking around, although generally they are either in knitwear design students' houses or in dusty old attics and cupboards, which have been forgotten about until they appear and there's a member of the family who has no idea what it is and just wants to sell it on fast. This is a great way of starting to move into learning about industrialization of knitting, because you're moving on from using a traditional knitting needle to the needles which you use in an industrial knitting machine, which I'll show you later as my tool. And it starts to, on a basic level, explain how the industrial machines work using butts and structure, and also it starts to teach you the advantages of industrial knitting, mainly speed and certain stitches which aren't possible using hand knitting, but also the advantages of hand knitting and the creativity you can have there. The advantage of using these domestic machines is it's still, every stitch is very easily controlled by you. You're not limited in any way. Then as education continues, you get to use these machines, which are called industrial machines, but are not a real industrial knitting machine. This is what you use whilst you're at university and get a very rude shock when you leave university and are no longer able to use them to reproduce any final collection pieces, but also you have no access to them, and they are incredibly slow, and everything still is made on a one-by-one basis and are human-powered. They are still helping grow your knowledge and expand your understanding of what a real industrial knitting machine is. So you have to start learning about how to use the two separate beds together and how they work in conjunction, and more of a technical basis. It's more difficult to, if you have a problem, fix it necessarily. You're having to test your skills and build them much further. Once I left the RCA, I worked for various companies. So this is a menswear company called Dodd. They are based in Elephant and Castle. And I was left out in the world with this knowledge of machines and all of these craft skills, but none of which I could use. I only had either my hand knitting or my domestic machine, neither of which can produce particularly fine garments or can produce fine scale, or can produce at a high speed. All of the companies that I worked for are small companies who have very small quantities to be produced. So typically they might want 10 garments and no more than that. This is another company that I worked for called Aganovich, which have further reach. They're a Paris-based company who show at Paris Fashion Week, and you can see that I produced a large range of scale of garments for them, from the very chunky hand knit on the right-hand side to the really fine lace on the left-hand side. And again, they're only producing maybe 10, maybe 15 if you're really lucky. But quite a few shops have bought them because they're high price items. And trying to get them manufactured involved talking to lots of factories, but they have very high minimums of normally 50 pieces, which is completely prohibitive for a small fashion house or designer. So a lot of the production ended up being produced by me, or I'd also work with freelancers to produce, which when it's 5 garments of each style doesn't sound like a lot, but when it's a collection and there's lots of different pieces in the collection, and I have 3 months to make 75 pieces, and some of these pieces, for example, the cape on the left-hand side would take about a week to make because it was so work-intensive, and also all of the fringing, it really built up and was not a practical or sustainable solution. So, current manufacturing works in a way that you produce one garment many, many times to reduce the cost. The biggest cost in programming a knitting machine is the programming and that human interaction at the beginning. You have to take your design to a factory where you speak to a technician who will program the machine for you, which can take anywhere up to half a day depending on the complexity. And then there is a lot of back and forth as you perfect your item, and also test it on the knitting machine should there be any problems with it. Now, if you're a very small company, or working on behalf of a small company as I was, coming with this small, generally quite technically difficult item that we were bringing to them, the amount of programming time versus how many pieces that we would order from them was so low that even if we got a factory to agree to work with us, they would often push us to the back, and we'd be calling them up every day asking, have they done it? Of course, absolutely, but we're not the top of their priority list because they're never going to get an order of 100, 1,000 or 10,000 pieces for them. So my solution to this problem was to get my own knitting machine. So this is a real industrial knitting machine, which I've been able to get with the help of my colleagues, Hal, Ben and Greg. And we have also been able to very kindly work with Stoll, who are one of the world's largest knitting manufacturers, or knitting machine manufacturers. So to also address this problem of not being able to produce things on a small scale, we have worked to create a new software where we can work with these machines and produce small quantities on a price point which is similar to creating 1,000 of the same piece as opposed to one. Just to also explain the speed of these machines, you can knit a scarf in about half an hour, completely finished, and it's just a little bit of finishing on the end. Or, as I also like to look at it, if you compare it to grannies, it's worked at about 100 grannies in a week. So, a popular misconception of the knit industry, there is not thousands of nannies hidden somewhere in factories. These are the machines that we use to produce your knitwear. So they're incredible pieces of machinery which are very hidden away, and we are trying to bring them back into the public knowledge and public interest. From a designer point of view, the designers and technicians are very separate people at the moment in industry, and I've been fully trained up on this machine, but it's quite unusual. When I went for training, everybody else was a technician. They didn't have the existing knowledge I had of working with the fabric and the understanding, which I found really bizarre because I couldn't imagine using these machineries without my existing craft knowledge. I mean, even looking on the software, on the right is what the knit software looks like, as you can see all the little stitches, and on the left is traditional notations for knitting, for hand knitting, and it all makes sense to me and I can put it all together. But there was a lot of people there who come straight from the cold to be a technician, and they have no concept of how these things work and why they work together. So so as a company, what we've created is a system where we can make lots of garments different for the same or similar price of making them all the same. Through doing this, we've been able to open up the market that you can actually have what you want as opposed to what you're prescribed to. I mean, custom is a huge trend, whether it's Nike ID or Levi's or your Cambridge satchel with your initials put on it. It's a really important thing. And I think one of the most important parts of it is bringing people's understanding of the manufacturing closer to it. So you can starting to understand a little bit about what happens behind it. But also to make that seem interesting is the element of play. So if anyone's been on the Nike ID website, for example, you can play on there for hours, just constantly changing and working with it and exploring what makes the perfect garment for you. So this is, so then we've taken this knowledge and put it into our company. So I've got another little video, should it work, to explain this.
When we started knitting, we realised there was a big divide between production and design within the fashion industry. And we thought it could be some really exciting opportunities by bringing the two closer together. Knitting isn't a fast fashion company, so we're producing very, very high quality garments made from pure merino wool that are hand assembled in the UK. Not only that, but we're involving people in the creation and the design of the clothing, so it's something we keep for a long time, and we're making it to a standard which means it will last. Part of the idea of knitting is making manufacturing more transparent. So at the moment in the clothing industry, it's very hard to know where your clothes come from or the conditions under which they've been made. Whereas with our system, because we're producing locally, you can see the process from the beginning to the end. And we think the future of fashion is really involving people in the process of creation and the process of design. Ultimately, we want knitting to be fun, and we want people to enjoy the experience of designing for themselves.
So, just so you guys can see quickly what our site looks like and to see the play that we have. So this is a demo website which is hopefully going completely live shortly. We've worked with various different collaborators, but we have this one which we did with Monica, which is a Netherlands design studio. So you start off with a traditional houndstooth pattern, and then as you drag over, you can create your own pattern, which can become quite addictive. Oh, sorry. Oh, I've got a really small, skinny screen. Okay, there is also a visualization of it on the right-hand side of the screen, which isn't currently there.
But this is online already?
This is not online fully yet.
But soon?
No, soon. They tell me every day, soon. So, yes. So you can see it uploads onto this lovely gentleman's scarf here. So if you can see, there you are. Yeah, so that's what we do.
Thank you.
You.
That's brilliant, and also a real life example of redistributed manufacturing happening now in Somerset House. Can we switch to the camera for a second while Dries... Can you have a few problems with your computer?
Don't worry, I can add some more.
Can you tell us about this
Oh, thank you.
tool that you've brought?
Yes. So, I don't know. Are we working?
Yeah, it's on.
Okay, then that's fine. So everyone knows what a traditional knitting needle looks like that you've probably seen at home in a basket, forgotten in a corner somewhere. But this is what an industrial knitting machine needle looks like. So based on the domestic machines and then the further industrial right up to a real industrial machine that I've shown you, this is the basic understanding of what the needle works in. And it uses, this latch to capture the yarn and build each stitch on top of each other.
So that's what's actually touching the material.
Yes, this is what actually makes the stitches. So there's the long beds that you see in the middle of a knitting machine is full of these. So my machine, which is a baby comparatively to most industrial machines, has about 1,600 of these.
Of these?
Yes, and this is only the head of it. There's another 4 parts to it, which are all controlled.
Great, thank you.
No problem.
Thank you. And we'll switch back to Dries. So we've kind of looked at practice that is based on a tool. After looking at a company that's based on the process, we're now going to look at a company that also really investigates the tools as products. Thank you.
Let's see. Okay, thank you, Daniel, for the introduction. So Unfold, we're an Antwerp, Belgium-based design studio. It's basically me and my partner Claire, a couple of interns, freelancers, and we're a bit of a networked studio in that a lot of our work are often collaborations. If you look at our work from the last, let's say, 5-6 years, there's this common thread running through it. And it's this question of what is the role of the designer today? If you go through the history of the designer, like the grandfather, the craftsman, he understood the whole process from designing to making and selling. Everything was combined into one profession. Daniel already mentioned it. But with the industrial designer, with the advent of the Industrial Revolution, it became more of a specialized profession and like one small cog in a big machinery. So he lost quite a lot of influence on the making process, and there were a lot of gatekeepers, people that were able to say no for a certain reason. What we see now, or what we feel, is that this profession of the designer is changing again and is regaining some of that independence and taking that profession back into his or her hands. And a lot of that is being made possible by digital technology, and not only digital manufacturing, but also the digital network, the internet, that's very profound in the ways we can share, the ways we can produce, the ways we can promote ourselves again. So a lot of our work deals with this question and tackles some of the different aspects around this role of the designer. For today, I'll pick out 2 projects that deal directly with tools and the making of tools and the importance of it. So I want to start with the oldest one, L'Artisan Électronique, which is French for the electronic artisan. It's a collaboration between our studio and interaction designer Tim Knapen, and it was developed in 2010 for Z33. It's an art center in Belgium for the exhibition Design by Performance, which focused more on the performative aspect of design versus only the final object. So if you look at it, basically it's a 21st century version of a traditional potter's studio. So it was a live studio, so we would work there, and on one end of that long table was a virtual potter's wheel, which allowed visitors to the gallery to throw their own digital pots, and I will just show the movie to show what that looks like. So this is a slightly different version, but there's a cylinder rotating on the screen in front of you, and when you move your hand in front of the screen, you cross a laser beam, and the profile that's projected on your hand is directly copied on the screen. And so you can literally push your hand in the digital matter and shape a virtual vessel or pot or a decanter or
some random chaos, which a lot of kids like doing. There's 2 buttons at the bottom, reset to start again, and save, and then it would end up in our database. The last 16 were always projected on the wall, and then we would work in the gallery to browse through that database, select some items, and then print them out with a machine that was on the other end of the table, which was a 3D printer that we customized, or we modified the whole print system. Like Greg already mentioned, the innovation is more in the tool head than in the positioning system. So we changed it. Instead of printing with plastics, it prints with ceramic clay. Again, here's a little movie. I think by now most people have seen how a 3D printer works, but it extrudes, in this case, material on a downwards moving bed. So layer by layer, it draws the object and builds a 3-dimensional shape. After the traditional process of firing, glazing, firing again, the objects were returned to the gallery and displayed in a set of cabinets. So what you see here is examples of what people designed using our kind of framework or our tool. And it's intriguing to see that you've designed a tool or a framework, which is basically a game. People start exploring it and finding the boundaries of what you can do, and then come up with things that we never would come up with by ourselves. So for example, the little sprout on the decanter is somebody literally waiting and then removing their hand very quickly, so you get that sprout. And the one on the left is a very thin, narrow one-flower vase. Here's another set, some traditional, some more random movements of the hand. Back to tools. This quote by Jan Middendorp was quite important for us because it was in an essay called Tools on the work of the Dutch typographic duo Letterer, who have always been for me a big influence because they applied digital tools in a very traditional profession, which is type making, and really explored the creative potential of that. What Jan Middendorp was referring to in his essay, and this quote says, "Programming is much too important to leave to programmers." And he was referring to the programming of design tools. So if you're a designer using digital tools, you're probably using Illustrator or Photoshop, or you're using 3D Studio Max or Rhino. And the design or the production or the making of that tool is being done by a company often in Silicon Valley who designs for everyone, who makes the tool for everyone. It's like quite a generic thing. And what is the problem with this is that because you're not making the tool, you're also not making your own tool language. And if you look again at the traditional craftsmen, they would always make their own tools, and they would appropriate them and hone them. This is an example from a Japanese swordsmith, and it goes so far that they're not even allowed to act out their profession before they could prove they can make their own tools. So they had to have a tool-making diploma. But here's the problem, that the skills needed to make those tools, you see a hammer and different sets of, I don't know how you, grippers. The skills needed to make those tools aren't very much different than the skills needed to apply those tools to make a sword. It's more like the more advanced level of it. But in the digital age, those skills of making digital design tools are very different. The skill is coding is very different from the skills needed to apply those tools. And it's not that nobody can combine them, but it's not an obvious thing. I tried programming for many years, and I always fail at it. I don't understand why the computer can't figure out that it needs a comma somewhere or a semicolon. But we were quite motivated to design our own production tools again, because we were always fascinated by this bridge between digital and the possibilities of it, the malleability of it, but refusing the screen as a medium on which the digital should be manifested. Because we like materials, we like the tangibility of it. So in 2006, I think, Adrian Boyer from Bath University started developing the first open source 3D printer, meaning that you could actually get this machine and intervene in it, appropriate it, and hone it to your own uses. It's extruding plastic like a glue gun does, so it squirts out this tiny roll of plastic material and stacks them on top of each other till you get an object. And for us, there was this immediate link with coiling. And coiling is the first technique that mankind basically invented to make objects. And for us, the 3D printer was basically a miniature coiling machine, building up objects, again, layer by layer. Instead of keeping this tool for ourselves, we immediately open sourced everything. So we documented the whole process online for everybody to imitate, to change, to appropriate. Because in this age, there's also no way that you can actually keep this for yourself. So you better open it up and get others involved. So this, for example, is Jonathan Keep. He was the first British potter, the first who approached us and applied this in his own practice and really takes it on a whole different level. So in essence, we designed more of a tool and then looked at what happens when others start applying that tool. But it also boils down to this thing that for us is very important, and that is, I think what we're all doing is take the tools of industry and bring them back to the scale of the studio. Because what the Industrial Revolution did is, or what we're doing is kind of reversing this blow done to makers by the Industrial Revolution, by taking these tools and bringing them back to the studio. There's one point that I want to look at in this context, is that when we displayed this for the first time and it travels a lot, often there's somebody who approaches you and is like, yeah, you know, do you have to make this perfect manual, nice craft? Do you have to make it digital? You don't want to make your hands dirty and things like that. First of all, I have to say the studio is always a mess when we print, so the hands are dirty. But also we came from the other side of things. We were looking at digital technology, at digital tools, and frustrated by the lack of tactility or hands-on approach in digital design tools. If I would be designing something on my computer in 3D Studio Max, you would see from that end no difference when I'm doing that versus when I'm checking my Facebook. It's just clicking, it's dragging, it's commanding, and it's lacking this very hands-on and very intentional action and feedback loop. So I want to jump from here, from this digital physical making tools to our last project, which we presented 1 month ago, I think, in part in Łódź, in Daniel's exhibition, and in the Dutch Design Week, which it's called Of Instruments and Archetypes. It was born out of the kiosk project that we did. I'm not going to dive into this, but it's about a near future scenario in which digital manufacturing becomes so ubiquitous that you see it on like street corners, and how a general public is going to approach that and going to apply it. For example, in copying, you might have seen it at the Design Museum, where we copied other contenders of the Design of the Year's Awards. But the project grew out of a copy that we were making in a workshop with students of this set of decanters by Christopher Dresser, often considered the first industrial designer, or maybe the last craftsman, I don't know. And when you look at this set of objects, you see that there's one typology. It's a glass jar with a silver top on it and a little stick that acts as the handle. But they're all very different. So how can you copy this? You need to copy the system and not an individual object. So we started looking at a similar way in which we can take a glass vessel, an existing one, take a little object that can act as the handle, and then create the part the connector that binds those two together and makes it into a small decanter. Of course, if you want to do this, you have to have an object, a three-dimensional, 3D printable design that is malleable, that has this flexibility built in so that it can adjust to all these objects. But then you need a tool to measure those real-world measurements and apply them to the computer. And traditionally, you would do this by measuring something, writing those numbers down, then going to your computer, write them down in the program, or sliding a slider, which was very cumbersome for us. So what we did is we took measuring instruments and we connected them directly via a wireless connection to the computer, so that the measurements would be directly transferred to a digital model. And I like how Daniel said there's like adding, subtracting, and making, I think the last one was shaping. Okay. But measuring is always kind of, it falls out of it because it's not directly applied to the making process. So the object that is the digital object is parametric, and that's a little bit what we refer to in the title with archetype. It's kind of this archetypical object that can still have a lot of different proportions and measurements. I'll show you the movie because it makes a lot of things a bit more clear. So here you see on the screen, you see the parametric object, and you measure and you cycle through the different measurements in the object that you can then real-time adjust. And sometimes that might be a real measurements, like the diameter of the glass or the wall thickness, but it can also be like the distance that your hand needs between the handle and the glass. So you can measure like almost a non-existing measurement. And this object can then be manufactured using 3D printing directly. So for the movie, it comes pre-installed with little screws. There you have it. What's interesting is when you do this, what I mentioned is that normally you go from measuring, and there's this intermediate step, and then you go to making. But we wanted to go straight from measuring to making, and make the measuring the actual making. What you see then is that you don't need units anymore. We invented units as a way to convert from that measuring to that making as the step in between, to write it down, to note it, and to transfer it. And I spent half a year last year in the US, and you see how units are quite influential in the way that we design. Students would always make something 1 foot, oddly enough, and a foot is not a nice measurement. So by removing it, we actually go back to a very instinctive process, which is this. How large do you want something to be? Well, something like this. Is that 20 centimeters or 21 or 21 and a half, 0.667? It should be very intuitive again. And when using units, we always round off to the nearest unit. So to end, I'll show the way we designed the objects. So we hacked actually existing digital measuring tools. So you see a little bit the sensor strip from a normal digital caliper, and then we removed all the units from it. So it's not only the first example you saw was like at-home 3D printing, which is always a bit. The quality is always a bit lower, but you can actually produce it at home and fix something or make something directly. This is printed in stainless steel and combines 2 little glass objects together. And what's nice is that the handle is actually a small little vessel itself. Okay, that was it.
Right.
Thank you.
So in a way, there will be a bank of lots of shapes that people will be working with. And that's very similar to your previous approach of putting things on Thingiverse.
Yeah.
So we are going just to see, so again, in terms of type of practice and sharing tools, Unfold have put online in a platform called Thingiverse the designs of the first, this was 2009.
Yeah.
And since then, we've seen a lot of people contributing and picking up through open design. and some people closing off some of the things. And this is another debate about tools, which is what do you open when and why. But this, can you just show us what the part that you invented? And
well, so what I wanted to find is a solution. You have industrial dispensing gear, which is so there's industrial dispensing gear, which is pretty expensive. It's also not working, is it? Oh. And I wanted to make something. An industrial dispensing syringe is the same volume as this one, but it's twice as expensive. So this is just one I get from the pharmacy, which is under €1, I believe. But there's no way to add the air pressure to that. So I designed a little part, which is 3D printed, that takes a standard pharmacy syringe and then converts it to a pressurized syringe. And this one we open sourced, and there's a couple of iterations already going on. People are improving it, also changing it, because depending on the region and the availability, not every syringe is the same size, so there's already a couple of versions for different syringes.
So people manipulate the
yes,
dimension. So in a way, this is a precedent to the digital tool project, very much.
Yeah. And it looks like if you ask about failures, the little screws, it looks like it's assembled, but it's printed in one go. And the little screws are there because you print something, there's this layering, this striation. And when you apply a lot of pressure to it, it breaks on those lines and it just flies apart. So the screws are there to take the stress and to keep it from flying apart.
And so I guess we've seen these 3 tips of things that touch materials, and there's nothing new about that. That's the kind of resolution that any maker really that knows the material. And when you hold a material, it's like this whole feeling about, is it going to break or is it going to perform? It's part of that knowledge that I think you called the downstream knowledge that you need in order to design the tool. First of all, thank you very much, Dries. That was, I think, really interesting to see how the project of making tools for other people start. I was going to, I don't know if this is working. This is working, yes, yes. I think that there's a couple of questions that are kind of interesting for me. One is to do with the kind of, so when you're designing the tools, thinking about the impact of the digital on your aesthetics or on the things. So how much is this enabling you and how much is it constraining you in terms of what you can do? So you talked about this kind of intuitive discovery and you're talking about creating a situation where people discover things while they're, but actually they're somehow constrained by what you call the parametrics of it. So don't you think it's really constraining us or you when you are working?
What, the digital tools?
Yeah.
The digital tools, I think, are the opposite in a way. They're so unconstrained that they allow you to... Yeah, the digital tools are kind of the opposite. They're so unconstrained that they give you this false hope that you can make anything. But in fact, we have to purposefully constrain the digital tools to the precise types of limitations that occur in sheet metal in our case. So how thick can the material be for a certain radius of fold? Because these are all curved folds.
So what actually drives the innovation? Is it the tool's lack of limits, or is it what you want to achieve? Because I'm not. Well, so what is driving the innovation for you?
I think the fact that despite the fact that these are industrial machines, and the same with Nitan, they can be appropriated and you can access them and you can get them to do what you want them to do. So, I mean, we didn't start with robots, we started with folding, and then I had to work out, well, how do I fold industrially? How can we automate that? Because I wanted that connection to the software so that people could design something and it could be manufactured directly. So, I think
you don't feel limited.
No, I don't. Well, there are limits in the materials. You can't just have anything. But if we can design within those constraints, and we know that those things are possible, then we can explore within those boundaries much more freely. So, I mean, if we first can have some boundaries, then we can be free within them, rather than pure freedom, which is, well, we can't build that because it's, it's impossible.
But you're talking about maybe the biggest thing is the variations, and for you, Kirsty, that's the kind of, I think, that slide when you say, okay, do it for the same price in the same time, but we can do a lot of different things. But actually, they're kind of fairly in the same territory.
Yeah, the pieces that we've produced, we are working within the same territories at the moment with what we're developing and offering out to the customer. But one of the things that we realised very quickly is that we created, first of all, a platform where you could draw whatever you wanted. I mean, we're working with Jacquard and Pattern, and you could draw any picture you wanted, but we actually found that that's incredibly intimidating for anyone being given a blank piece of paper or a blank jumper. And also, because it's something you wear, or if you're designing it online, quite often, if it's a plaything, you might be doing it with someone else, it's opening up who you are, and it's showing a little bit of your personality that normally you don't kind of get to show until you've decided that's exactly
So what's
right.
driving the actual innovation? Is it the expression, or the material, or the actual making, or is it the tool?
I would say for us, it varies a little bit between the group of us. So for me, it's the ability to express yourself. But equally, we also find that bringing manufacturing and creating new ways of opening manufacturing incredibly important.
And for you, Dries, I mean, this kind of, there's a pretty kind of archetypal, you're using archetypes to kind of demonstrate principles. Is there a frustration with the results, or does it matter?
Well, that's two questions, I think. The use of archetypes for us is because a lot of what we do are installations that end up in a museum, and you're trying to tell something, and by using archetypes, you tap into an existing or something that people can understand, and then you apply that new layer to it. In regards to digital tools and frustrations, I think because first the making of the tool was so that we would have our own language and have the tool marks. When you design a tools, they leave marks and they create a language in your product. But by open sourcing it, we of course, everybody now has that kind of language, and it's something we start to become quite aware of, and people also gave that comment, like everybody who 3D prints in clay has the same kind of language in it. And I think that's quite, it's always something that happens in the beginning, where you have a process and that leads to this language, and you keep that intact. Like in traditional people, potters throwing on a wheel, you also have the people that leave the marks of the hand. And there's others that like to remove the traces. And I think everybody's now keeping all those traces in there to show how it's being made. But I think slowly we'll evolve in people using ceramic 3D printing, but actually removing all the marks and creating new marks.
And
So
I guess while we're going to open up for questions, while people are getting ready, how do you feel about tools? What's your how would you describe your relationship with tools?
I think it's pretty important. I think having experience not only with the tools but the materials and their relationship to each other and the feedback you get from those is pretty important. I think that's a thread that's been running through these conversations. Again, is that without first understanding the materials and the tools, how do you then digitize those?
But do you see these as friends or enemies, or how do you feel about the actual things, or not at all? I don't know.
I find
dependent.
This one is not so clever. As I said, it's quite a sort of dumb tool. So I want more intelligence in the tool itself. I want to put more intelligence in the software.
So you trust it?
I trust it, yeah, but it's a bit static. So perhaps we could automate the tool more as well as everything else. So more automation is good.
Okay. And for you, what's your feeling about kind of the? I mean, you have your big knitting machine, and is that the lifeline, or?
Yeah, it's my friend and colleague. We work together. I'm renowned within our studio that I've given all of the machines that I work with names. So we have Herman, the German knit machine, in the studio, and in our shop we have a second one called Helga, who's his girlfriend. So I give them all a story, and they're part of what I work with, and you know, it's a mutual thing that we have to work together. If something breaks within the machine, I know that it's equally probably, it doesn't just break on its own, it's something to do with my relationship of me not understanding it, which is just as important.
So you don't just blame the tools?
No.
But what about you, Dries?
Maybe, well, let's see. I think less than maybe the two others. We're less married. Or I never wanted to spend now a lot of time in developing this tool, like ironing out all the kinks, and because I lose my focus really quite quickly. So that's one reason why we threw it out and open sourced it, because I really wanted a company to pick it up, improve it, and then I would be their best buyer of it.
So it's not an ownership relationship.
No. So I always have this kind of, it's almost a necessity that I design them, because I want a certain thing, so I start building that thing. But then I often think, okay, now I showed that it can be done and how to do it, and I rather have somebody else than doing that extra 80% of the work to improve it.
So it's kind of a member of the community rather than a close friend.
I'm more interested in what I can do with it than spending all my time on the tool itself. So I always have kind of a... we only give the machines a name because they all have quirks, so we remember that one doesn't do this well, this one always
So what are the names?
They also change. We call them after robots and after this and that.
So do we.
Yeah, so there's Alvin and those kind of things.
So we're going to open up if anyone wants to ask or raise any comments. We have one here and one after that here, please.
If you just mention your name, please, before you ask the question.
Hi, Amanda Bright. Question for Dries in terms of when the object's been printed in clay, is there any temptation then to get your hands back on them and sort of personalise them further? I mean, the kind of personalisation that comes from the individual creating the form in the first instance that then is produced through the machine. Is there something about touching the clay further that's possible?
Not so much. Apart from glazing and all those kind of post-processing steps and playing with the firing in wood-fired kilns and those kind of things. Because I in that sense, I'm always a little bit a purist, that I like the traces of the process and leave them intact. So I know, for example, we've did this project called stratigraphic manufacturing, in which we tapped into that network of everybody who took our technique and applied it in their own practice and used them as a distributed manufacturing. So we send out, we emailed digital designs and asked them to produce it, but leave that freedom to use local influences and clays, etc. And then you see that a lot of other people do that. They really apply. We only apply transparent glazes, but other people apply like very thick colored glazes and remove the traces or do a lot of. I always leave all the little marks and where the tool head moves in and out, little mistakes, I leave them in. Others start to take them out, etc. So it's a matter of preference, but I always like to have it almost as it comes out of the process and just leave it like that, like a potter that throws on the wheel and leaves all the marks and just glazes and fires. So preference.
So we have 2 questions here and then one forward there and then back.
I was interested in the idea that making a spout seemed like a little bit of an effort. You know, you had to sort of suddenly pull it to get a spout.
Well,
And
it's not an effort. You have to do nothing, basically.
Or you mean you have to stop doing what you were
Yeah,
doing,
yeah.
and then you get a spout.
Yeah.
But I mean, it is, as you said, it's a sort of digital potter's wheel, which implies it's going to work on the roughly on the idea of a cylinder. Is it also easy to make things that don't even start there, that actually are more free form?
It's always a little bit the game we have in the studio. Every intern has to throw a square, so a cube, and the best cube always wins something. So I think on a potter's wheel you always start from a cylinder, right? It's cylindrical motion, and then you start doing it. But of course this whole installation was, like I said, a narrative. We never intended to make this 3D printer so that you could make a simple vase or something like that. So after that, we started also understanding that actually a traditional vase with a thin wall is the worst thing you can print because it's very unstable. So after that, we started exploring printing with, maybe when it's on my desktop. So this a bit the technique that's being used in Gothic architecture, where you have all the scaffolding being built into the cathedral. So we print most of the things we design now from scratch for the process, understanding the process and reading what it wants to do, are things that are not a single walled object, but a complete structure that's actually keeping the object scaffolded while it's being printed.
We're going to move on to another question.
Tony Quinn. I'm really interested in how we have to humanize things, because the Philly Lander was tweeting, and it was anthropomorphic. It was talking about going to sleep and how we all have to give names to our tools, to make them somehow less dangerous. I don't know what the question is there, but I'm interested in the phenomena of giving these things a name and giving them a life and making them more normal.
Yeah. There's another question behind. Just
Siri Clark. Kirsty, I was interested in the Nitan work and talking about the idea that users are put off by having a completely blank canvas. And you're kind of starting with patterns, but you're working with kind of preset shapes. I know in your presentation you had kind of different size jumps and so on, but you're basically working with standard structures and then allowing people to apply a kind of 2D pattern on top of that. Do you see in the future being able to completely imagine the shape from scratch?
Yeah, currently we have done it that we've got set garment shapes. That's for a number of reasons, partially because it means that if you get something you know it will fit, as it's got my years of experience hard-coded into the garment already then. And also because knit changes so much depending on the pattern density. So we've done a lot of work based on pattern density and how that affects the patterns, as in the garment shape pattern, sorry. So in the future we'd like to be able to offer sort of different garment lengths and things, but to start with we want to step through the process as slowly as people get used to the different areas and learning about what they want and what is right for them.
Good. We can take one more. There's right at the back. And then back to here, which they've... Brendan, and the last one just here on the 4th floor. Here, can you lift your hand? Yeah.
Hi, I'm James Smith. Question to all of you actually. As we move from push economies to pull economies, is the role of the craftsman shifting from bespoke maker to bespoke facilitator?
So the issue of creating platforms rather than objects, yeah? Greg?
Yeah, I think that's really important. One of the ventures that we've created is curvefolding.com, which is somewhere where we showcase not just our design software and results, but lots of other people's design software and the things they've made and the things they folded by hand. So that's, I think, pretty necessary to facilitate people's exploration without trying to claim it commercially.
The shift of the practice from doing the things to doing the places where people can make the things, or?
Yeah, I'd say it's actually more of a shift further backwards as we're going forwards. People used to create their own clothes at home and make them at home, and that ability has been lost through a number of reasons of society and things, but also it's just so expensive to make your own garments. If you want to go to a knitting shop on your high street and buy the yarn to produce something, which will then take you, depending on how committed you are to knitting, a few months or a couple of weeks to actually produce, it's a huge commitment of time and money, whereas using a system that you know what you're going to get out of the end is, I think, really important to people today.
So I think that's kind of veering towards where we want to sum up around the relationship to whose skills and whose imagination is playing part in or being enabled or limited, or what's shifting in that territory. We'll take one more question.
Yeah, Julia Lohman, I've got a question for Kirsty. You spoke about this relationship, the collaboration you have with the engineers, and I was wondering, how did this come about, and what do you think we have to do to make more of these collaborative practices happening?
I was lucky enough that I was actually friends with them, so which made it a little bit easier. But when I studied at the Royal College of Art, I met Hal and Ben there, who previously had studied both mechanical engineering and electrical engineering at Imperial, and then brought Greg in later, who they'd previously worked with. So Ben had already made the step to come into the creative world. It's quite difficult to get people to meet. I'm not sure I have the answer of the best places to get these people to meet, but it's just making the arts more available and for people to not see it as an exclusive or closed off club.
Great. Thank you very much, all three. It's been really great to have insights into the actual use of the tools that you are pushing about, but also it's very clear that there's this whole dependency with the materials that these tools are touching and manipulating, and the knowledge of the using these tools. So I think, in fact, we've been in 3 different sessions, but would have been great to have the 3 sessions going on at the same time, because that's what it's about, really, these 3 drivers that work together. And one of the things that strikes me very strongly is this continuum of the human body into the tooling and the use of the tooling, but also the continuum of very early tools and how they are really present in what we're calling new tools. So what is really new in this whole? Is it the way we exchange knowledge that is new? Is there new knowledge that is being added? Yes, I think so. Is it replacing old knowledge? I hope not. It's really building up in layers. And I think also it's really great to see people that are bringing the digital and the physical so strongly together in your practices. And I'm really looking forward to seeing the next time that we get to see your work. So thank you very much.
Brilliant. And thank you, Daniel Charney, as well. Thank you, Daniel. I have to say, currently trending in the hashtag is that 1 stall equals 100 grannies. So congratulations. It's our big takeaway today. So please do come back at 12:05. We've got our 3rd and final keynote speaker, Amar Machan. So don't miss that. Do grab some coffee, stretch your legs, and we'll see you back here shortly. Thank you.
Thank you, Brendan.
It was a very good session. And well done for the later start.
Yeah, you were pointing out.
Because I was looking at that and I was inspiring, so thank you very much. I'd like to speak to all of you individually, maybe later if I can get to you, but thank you very much.
Thank you.
Yeah, unfortunately on the demo website, this bit doesn't
Mine's
show.
robot. It's strong. You can handle it. Hi, Greg.
Which shows this instruction.
Okay.
There's
Question for you. The applications that you showed are part installation.
So they're all like individual little apps.
They're being used for more commercial things rather than just
Hi, my name's Henry Hill. Hello, and that's what I made.
Okay,
they're made by hand.
Yeah.
I'm embarrassed to say. So, I don't know how much digital printing in ceramics are you actually doing, or are you mainly not doing? Because you use stainless steel as well.
Yeah, that's outsourced. That's using commercial 3D printers.
And is your ceramic stuff outsourced as well?
No, we do all of that ourselves, but we only produce for our own projects, so we don't.
And they would be for like industrial parts, that kind of thing. It wouldn't be for.
No, we only produce for our own projects. So we're working, for example, now we're collaborating with a French perfumer. We've developed perfume diffusers.
Right.
So it's quite complex objects with internal structures.
What are they made of?
All different kinds of clays. They're all quite low fired because they need to be porous. Yeah. Most of what we do is ceramics. So.
I suppose what I'd like to know is who, without me having to come to you, although I don't mind, but who are the main people who are dealing in ceramic digital printing nearby?
First you have to split it up in different techniques. So what we do with extrusion is probably the closest to traditional ceramic techniques. It's using soft clay and building up
This
from
is
that.
extruding. I use a cake icer. So, I mean, it's all extruded using a clay slip which has paper in it so that it holds together. But it's not done digitally. I sort of think, having been here...
First off, why would you want to do it?
Because there are some shapes I can't make.
Okay.
I'm not very good at curves. I'm struggling with doing a dome at the moment. I'd like to do a form inside a form. There's lots of things that your little set of samples seem really interesting.
Well, at the moment, mostly what we do is refer to all the techniques that we've documented. Okay, thanks. Yeah. And tell people like, okay, you can build your own machine and develop your own, instead of outsourcing it, start playing with it yourself. Which is, and Jonathan Keep that I showed in the presentation, he did a lot of work on developing simple machines. Without IE. Just Keep.
I wrote down Keep. Because he was doing things that are far less based on a circle and they're just freeform.
Oh, yeah. Well, you can
work.
Suffolk.
I mean, he'll have a website.
Because he's doing a lot of the ceramic printing, almost.
He does it himself.
Yeah. He took our documentation. We're doing a project now. He's coming to us this weekend, and next 2 months we're doing 4-week residency in Sweden, working on glass blowing with printed molds and things like that.
Does he do? I don't know whether it's Rhino or something. But does he do that part of the work?
He uses.
And I put this in when you built.
Yeah. Okay. But I don't know if it always boils down to the thing that we all have enough work for ourselves, so we're not really taking to produce for
Try.
Right. But
Tuck this in your pocket. Yeah, sure. Just take a bit of fun.
It depends a bit on whether he connects with it or not. But there's also Shapeways. It's
alright, cheers.
3D print service.
I'll just play a video and see if that works.
Take industrial 3D printing.
So how about
so you can upload a 3D model and then instantly get a quote in different materials. And they also have a ceramic
based in
process.
London or where?
No, they're in New York and
it's fine, huh?
As long as it's not on mute, I'll turn the volume up.
I don't even need sound. I mean, maybe you can play it.
Layers of powder that are binding.
Well, I'll see how it goes.
Alright, so how about the clicker?
Yeah, but instead of heat, it just uses water. Water and some other.
Is that ceramic?
Alright.
It's ceramic, yeah.
I mean, it actually doesn't matter particularly, but I'm quite interested in the ceramic aspect.
No?
It's clay powder. Yeah. So the only thing is it's not compacted. So it's not, it's quite porous, and they glaze it already. So it's a bit, if you want to do your own things with it, it's.
Yeah, I mean, it doesn't matter. I can just click also here.
Well, this is the thing.
Yeah, have a look at it. Yes. They're, it's just a matter of ordering it. They produce the parts if it's within the design limits, etc. Okay, thanks very much. You're welcome.
Never mind, really.
Yeah, I'll put it in. Have you got a card? Yeah.
Yes, it's okay. Yeah, just plug it out. Thank you.
I thought I'd come say hi. My name's Dan Howe. I thought I worked for Disease.
Oh, hey!
How you doing?
Cool. Nice to meet you. Nice to meet you, yeah. It's always so fun to because there's always like email, blah, blah.
We're actually doing a series of interviews as part of the
Okay.
conference. I was wondering if you're sticking around a bit later on, if we could catch you for 20 minutes or so.
Yeah, but I'm not too long here because I'm catching the train. I need to get the train. 3 o'clock.
Okay. I've just got my camera guy is here, so I just need to double check with him what we're doing. But if I can grab you in a second.
Yeah, okay. Cool.
Make sure we get slowed down. Great, I'll be back in a bit.
Okay.
Yeah, feel free.
How much do you know about the whole 3D printing before you
Oh, how much I knew about it. What do you mean? What
did you learn about it as you were doing a project?
Well, I've always been following it. So I've used, when I was studying, a little bit of 3D printing, but it was all, I never liked that it's such a black box technology. You send something and then you get it back. So I wanted to understand the processes and aspects. So you do learn a lot while building it. And I think I learned the most during the last 5 years of being like in that. Suddenly you're in the industry.
Okay, I'll hang around here, are you? Or are you gonna?
Yeah, is there any food actually?
There is. We
just get some water.
5 minutes. Oh no. If you want.
Don't worry.
Sure. Yeah, I was thinking, kind of, if Mar disappears, how are we going to? Nobody will come back.
I read you're an aeronautical engineer.
Yes.
So you can do the talking.
I'm going to mention that.
So I might forward some of the questions to you then.
If there's any. If there's any on that, we can. Yeah. Actually, I'm not going to even begin to hint that what you're, because some people may not know, and I was thinking, I'm not going to say, I've got. It's interesting because it's a drone. I just think all that.
Yeah, that's fine. I'm anyway going to end with that. So talk about industrial robots first.
Yeah, brilliant.
Maybe it's important to mention that this is not all my work. So I'm basically from a research group, right? I don't know. So basically, it's I don't know what you have.
Well, you can say I've got.
Yeah, I mean that's fine.
I've got your kind of standard opener. Also said that you're so new. There's nothing embarrassing on the internet about you yet.
Fair enough.
So I think if you mention that, but it's
I can do
collaboration and all that kind of thing. They love that. The audience love that. No, it's really interesting. Have you tested any video stuff? It's all fine. It's all fine.
It's a bit tight with the cable, but I think it's all right.
I'm going to eject these off the tank.
All right.
Yeah. Throw us out.
Not have the conversation there.
Gives the students the opportunity to.
You can only find out when you do it. What's the sense of it? Always a question of how deep you go, how much you can turn it into your own battery.
If you go put a robot on the road, no one's going to do anything.
Yes. Sorry, that's yesterday. No, sorry, we're fiddling with
Oh yeah, so at the end, when you finish, I'll run around and do some questions. So either you can say thank you, and I can step up and say any questions, or you can say, but we'll just play it very casually, but I'll do the running around for you. Yeah.
If there are questions,
Yeah, there will be.
I think so, yeah.
I'll have lots. No, don't worry. I'll have some, but... I'll give them a few minutes Because we're waiting to
no hurry.
And you're okay for time? I mean, as in, like, do you want me to give a subtle? I mean, you're
like
on,
a 5-minute warning would be great.
Yeah. So you're. I mean, we've roughly got.
How much do I actually have? I have half an hour, right?
Yeah. So it'll be about half an hour. Let me give you at least a sort of. Well, it depends. How long do you think? How long would you like your talk to be, and how long would you like the questions, roughly?
No, half an hour is fine, but yeah, it depends a bit. I mean, if you warn me, let's say, 5-10 minutes before.
5-10 minutes before the final end.
And then I can really speed it up or make it a bit slower.
Okay, so maybe I'll give you a warning, maybe 10 minutes before I think our session should finish.
That's fine.
And then you can time thinking, okay, I've got 10 minutes, I want to cover this final bit, and then I'll have the rest of the questions.
Sure.
Okay, so I'll leave it so 10 minutes before the end.
Thanks.
That's great. Thanks very much. Yeah, really interesting.
Yeah, well, if you guys decided to get...
Well, we've got some funding to...
Yeah, that's really good. Yeah, it's good team.
Everyone's so...
Just get some water.
Remember what it means.
Well, everyone's like, well, I passed by.
My colleague is just setting up at the end of the walk.
We're helping the university set up a flat lab, concentrating on robotics, sensors, machining stuff. So the same stuff is we're using for our processes now. So
Okay. See you. Thank you.
Spend more time on the process. Sounds like you've got this craft sensibly ready.
Well, I think it's, as everyone said, it's a study.
What's the sort of timescale?
Well, it's just been
The guy in the room.
Hey Greg, I'm Amar from Grammatiekolder.
Ah.
Yeah, how you doing? Yeah, so I'm going to show some robots again.
Yeah. Well, one part of my talk I didn't show was a whole load of your projects, but this wasn't time. I just wanted to give a
that's good.
overview of all of
a little overlap there, but it's fine. Yeah.
So it's good to have what's your role in
I work with the flying machines.
The what machines?
With the flying robots.
Ah, okay.
So, yeah. But yeah, so.
It's
little,
really
little,
interesting stuff.
yeah, you know. I mean, you've been there, right? You've did a workshop there once.
There,
yeah, it's just before I started there.
Yeah. We were privileged enough to be allowed to do a workshop.
Oh, come on.
Well, we were told they don't allow outsiders in.
Really? Okay. Yeah. But yeah, it's been a while. I mean, it's changed a bit since then, I think.
Yeah, same stuff, just more software, I guess.
Yeah.
The more we can put everything in software.
How's that going with the software thing?
Yeah, really good.
Yeah? Cool.
The robot software is really built to solve problems, and at the moment there's a lot of problems with robotics, and it's just so complicated.
Yeah. Are you doing this alone, or are you working with that?
We have a company.
Yeah. Okay.
Lots of people
Yeah.
away and stuff.
Okay. Yeah. Cool.
But yeah, we might come over at some point to see the NCCR.
Yeah.
And show everyone the software, because I know I was talking to Matthias Robarge about the amount of effort that's going
There's
on.
a bit of a discussion right now on the platform and everything. It's too much going on, and it's like we don't really have one library we work with. It's everybody's having a little bit their own tools, and now it gets so big with this NCCR. It's a bit yeah.
Yeah, well, that's the kind of problems we're trying to solve. Is just like keep the robotics bit to a minimum.
Yeah.
So you work on the process development, and everyone can have a very simplistic way to debug the robot and get it working.
Yeah.
Because that's the most important thing, because it's going to run. But then, for you as a designer, the important thing is, like, I want to design this process to do these things.
Yeah, sure,
so
sure.
you're going to spend more time on that and less time programming.
Yeah.
So that was the idea behind it.
Yeah. Yeah, it's cool.
Got a lot of good feedback on that.
Yeah. So that's going to they use different robotic arms, or you can use different robotic arms for that.
Yeah. So we just started with ABD. We've just added KUKA, and now we're adding the universal robots, which you guys are using.
No flying machines yet, huh? Yeah.
Only arms.
Your presentation's okay.
Yeah, it's work. Yeah, sorry.
No, don't apologise. I was thinking if I start talking, people start drifting in, so I'll draw on
it's
a
good.
bit whilst the presenter.
Welcome back, ladies and gentlemen. I'm hoping by the power of just hearing amplified voices, we'll get the few stragglers to come in and take their seats, because I don't want them to miss the start of our third and final keynote from Amar Machan. I think I was looking at Amar's work, and being an aeronautical engineer, I was really, really excited. You'll see why in a little bit. Amar's work is so new and cutting edge, it's actually difficult to find anything embarrassing about him on the internet. It's actually, I mean, I think that's a good measure of just how new his work is. He's an architect, a machinist, and a maker. His work focuses on the coupling of digital design space and physical fabrication space with robotic systems. He has a background in automation and engineering and has studied architecture in Switzerland and in London. After working in different architectural practices, Amar joins the Professorship for Architecture and Digital Fabrication at ETH Zurich, and he's been working on a series of research projects exploring robotic material practices with wax, clay, concrete, and metal, and has taught various international workshops and lectures, including Fabricate, RMIT, how's that, IAC, do you say IAC? IAAC, and
IAC.
Others. Amar's currently pursuing a PhD in architecture, investigating the design potential of materialization processes with flying robots. There's the bit I'm interested in. Over to you, Amar.
Thank you so much for the introduction. And thank you very much for inviting me. Does the microphone work? You hear me? Okay. I'm working in a research group at ETH Zurich that is led by Professor Matthias Koller and Professor Fabio Gramazio. And we're interested in, generally speaking, in design processes and how to fabricate those with robotic processes. So the tools we're working with are mostly robots. And following the session topic, I try to categorize a little bit how we use these tools, and I'm going to show 4 projects according to these sort of categorizations. So I will start with showing how we use the robot as a generic tool, how we make it more specific then, and how it recently is sort of used as a tool that is adaptive, that can recognize the environment. And the last part will be sort of an outlook of what I think is going to happen, probably in the near future, that are tools that are perceptive, that they don't just recognize the environment, but also recognize themselves, so they can act based on things they've done themselves. Now, there's a lot of myths and stories, narratives of what a robot is. I found this image from an exhibition at the Crafts Council in the US from '84. There's a lot of different functions that a robot can have. We are mostly interested in the machine here on the bottom right, which is having the robot as a generic, as a machine that can do multiple things. So basically, a robot is just a reprogrammable multifunctional machine. And it can manipulate materials in different ways through programmed motions. So we're interested in using the machine as a generic machine. So it's not a machine that has a specific function. And the machines we use we most work with is in so-called industrial robot. And Greg already gave a little bit of an introduction of what that is. So basically, these machines are not new. They were developed in the 60s. They're commercially available since the 70s. So this was the first 6-axis industrial robot that was developed by KUKA. And basically, they all work the same way. Usually, the 6-axis machine has 3 axes to put its end effector, sort of the head, to any point within its working range in any given orientation with the 3 axes that are mounted on the head. That's why it's 6 axes. And they're mostly used, as we know, in conveyor belts for the production of identical parts, for example, in cars. And that's, this image is actually from a company I worked for 4 years, so that's sort of where I'm coming from automation itself. Now, I studied architecture, so interested in how to build with these machines. And there are attempts of doing that from the 80s mainly in Japan, where the concept was to build structures with robotic systems to automate construction. However, there is a big difference between a car and the building, which is mostly that buildings are one of a kind, so they have to be different every time often. And so basically these approaches were not really successful because they couldn't adapt to different design situations. So a bit less than 10 years ago, at ETH, we started working with robotic arms. And maybe what's different here in comparison to the conveyor belt of the production of cars is that we are not so much interested in automating a process, rather to using it as a design tool. So we're interested in relating the virtual design space, and where we design and where we draw things, to the built space. And the robot is a tool that allows us to link those two spaces. And we're interested in the large scale. We're interested in the one-to-one in which architecture is materialized. So what you see here is a project from 2006 where walls were produced in our robotic cell and then brought on site to build this winery here. So the machine that is doing this is generic. So basically, we can put any kind of end effector to do any kind of things with it. And I'm trying to now show this in another project, which happened last year ago at RMIT, where we did a workshop for 1 week. Our building material were these aluminum profiles, and we wanted to find out ways how to assemble those into structures with the students. And we were joining those with glue, and I'm coming back later to that why we use glue. We defined certain constructive constraints for the students to work with. We wanted that the elements are joint planar in a way, so that they're more stiff, but we allowed that they could rotate and they could also shift. So the students would design assemblies of these according to sort of manufacturing constraints they will use later. And they created these sort of branch-like structures. And also through algorithmical control, it's possible to draw things on the computer we couldn't build by hand. For example, what we see here is that we reconnect sort of the branches to make them stronger, but this is only possible through computation, meaning that we couldn't actually know, if we would do this by hand, we couldn't know in what orientation each element has to be, so that it actually reconnects. These are some of the designs that came out from the students, and the information from this process was then translated directly into the fabrication cell. We see here is the machine we worked with, and we always fed an element from a base station. And according to the digital model, where basically all information is contained of how this element has to be in space, we sent this instruction to the machine. And maybe in comparison to the brick projects before, we're using here all 6 axes of the machine to put the element at a given position, at a given orientation in space. What the robot basically does here is show the students where the element will be, to sort of give it the possibility to mark it. and we had to treat the aluminium with an activator so the glue would stick properly. And the students are mixing the glue with this glue gun here. And this is then applied on the elements. And we had long discussions how we want to join these elements. Of course, there's other methods. For example, we could screw them together. We decided to go for gluing because if we would screw them together, first of all, a robot can't really screw something well together. So that's why we're looking at processes that are maybe more suitable for robotic processes. And gluing is something that is used, for example, in car manufacturing a lot, so where parts have come together. But also, if you would screw them, we could, for example, mark where the elements would come together and maybe pre-drill the holes. However, we would sort of lose the information of where they are assembled in space, and then the human just becomes an assembler of the structure. While here we can really translate the three-dimensional information from the design environment to the built environment. Now the robot is actually holding the element for 5 minutes for the glue to cure. Again, that's something a human couldn't do, to hold the element in space at the right orientation for 5 minutes without moving it. So we built sort of branches of these in space and then assembled them together in a gallery space. The structures were up to 4 meters tall, and it was interesting to see that basically you couldn't see how they were joined together. So the machine that generates those, as mentioned, is generic, but also the building element itself is generic. They're all the same elements, but how they are put together makes it specific. And sometimes I think working with generic elements, with generic machines, gives us more design freedom to actually work with it, rather than if they're all predefined and all individual. So what we see here is it basically resembles exactly what we have in the virtual environment. But that's only possible because also the elements are discrete. And this brings me to the next thing I would like to talk about, is the specificness of the tool. In this case here, we're working with granular materials, or unpredictable material that is not as clearly defined as, for example, the brick or these profiles. The project lasted actually over 2 years. We were working with different materials and different forms of manipulating the material. We started with sand, and basically what the tool does here is just dropping sand from a certain height. And depending on the height, it sort of resembles in the materialization of the process. Now, sand is extremely difficult to simulate, so we're using here a small sensor to see how the material actually drops. So the tool actually here it's quite simple, but it sort of follows the logic of the process. It allowed us to build landscape structures like that. But other than just dropping sand, we were also interested in forming and pushing material away. And again, this tool was made maybe in 5 to 10 minutes, but in combination with the robotic process, allowed for quite intricate material behaviors. And a third thing we tried was to work with molding sand. So this is oil-bound sand that is used for metal casting. And here we're not dropping and not pushing sand, we're actually pushing it together, so compressing it. And again, the tool is just a simple pyramid-like thing that just pushes it down. And just from basically you have different orientations, you have different pressures, which allows for this formation of the material. And we use this as formwork for concrete casting. So we pour concrete directly on the formwork, and you could then actually reuse the sand. This is an image of the negative and the positive. Again, a picture of the concrete. So with this process, we were invited for a workshop at IAC in Barcelona, and that's exactly the process we wanted to do there. And we prepared the tool at home, we wanted to take it there, but we couldn't bring all the sand because it was too heavy. So we asked them to buy exactly the sand, the molding sand we're working with. And when we arrived, that was the sand they got for us. So it was actually a lot more, but it was just clay. And so it was a 1-week workshop, and so the students had to, we allowed them to do their own tools, and we showed them the nice images of what we had with the molding sand, and it really didn't work with the clay at all. Basically, clay can't really compress, it just squeezes to the side. And I think the students were actually a bit frustrated with the results that we got from that. And also they sometimes spend a lot of time on making a very nice, intricate tool by like this moon-shaped thing here, but I think the result itself doesn't really reflect this thing. On the other hand, then, because we were confronted with this material clay, we tried to react to that by making tools that we didn't think of. For example, we made a roller. Again, that is extremely simple. It's just some angles put together and a cable roller with some tape around it. It's again like a 5-minute thing. But it sort of allows us to work with material in a different way. It's still squeezing it to the side, but it reflects more of what you can do with clay. And so I don't know if you see this black tape is sort of wound in a spiral motion around it, and this then also reflects on the clay itself by generating these diagonal lines. And we also cast concrete on it, so it's again the idea of you could use that, you could use the clay again for a different kind of panel. And that was the positive of the thing. And in the last iteration, we made a cutting tool. Again, very, very fast, very dirty, but that's, again, it worked really well with the process of clay. So by just cutting away material rather than stamping it. And this was, it was a bit fragile, so that's why we didn't pour concrete on it. We used plaster. That was the positive of the plaster. So again, the machine is very generic, it does this, but simple tools, very specific tools made for this process allow to generate forms that are sort of true to the material. Now, all the projects, or all these processes basically follow the same principle that you draw something on the computer, you translate it into machine instructions, and the machine executes it. So it's a sort of a very deterministic way of production. And with the next project, we try to question that a bit by incorporating sensing, so to see what actually happens within the process. And that's a project from a few months ago in St. Gallen. And the concept here was that if you want to build on a building scale, which is a bit tricky with a robot because it's usually more at a building component scale, you would have to build a huge robot to build a building. Or, and it's the approach here, is to use shooting. So it's sort of a ballistic approach where the material is just shot in a way to build the structure. So you extend the working range. And we used scanning to deal with the sort of unpredictability of the material here. We're working with something similar like clay. It was clay mixed with sand. And that was then shot to build sort of wall-like structures like here. Quickly show the process. This was a first wall experiment here. It's a bit speed up here, but you basically see the way the material falls can't really be properly predicted, or at least we can't really properly predict how the material behaves when it's during the impact. So the strategy was, in this case, to incorporate a sensor to measure what's actually happening. So on the ceiling, we had this scanner that would feed the information back to the design. So it becomes sort of a circular loop in the production line. And you can adapt to, for example, tolerances, but also mistakes. Show the machine a bit better here. The robot that we use here is actually a really small robot. And that shows the design software where we generate the trajectory continuously according to what we get back from the environment. One big problem here was, clay is quite soft still, so we needed some fans to dry the material continuously, because otherwise it would just flow away. And we see here sort of the build-up of the structure. And this is a visualization of the scanned result. You see how it sort of builds up on it. And this concept opens up certain questions also, like how defined does the design have to be before you actually go into production? Or, I mean, in this case, we're trying to deal with tolerances. We try to fix maybe what doesn't work properly, but you could also like react to maybe mistakes to generate something new. So there's the design can in theory be sort of indeterminate. Some pictures of the final result. So that's the highest points were around a bit more than 2 meters, but it's still quite a lot of material that we had to shoot here. And this brings me to the fourth point I would like to talk about, which is the ability of machines to know themselves, to recognize themselves. I think we heard about this already more than once the last 2 days, but I think it's interesting that we're talking about the industrial revolution right now. And I'm not sure whether it really is an industrial revolution. So The Economist called in 2012 the third industrial revolution. Chris Anderson calls it something similar. But I think it's interesting that the machines that are enabling this revolution are already existing actually for quite a while. So, I mean, the robotic arm was developed in the 60s. It's commercially available since the 70s. And that's sort of a picture on the left shows the first ASEA robot from 74, and that's a picture from our lab today. Even the color is the same. But also CNC machines, they're existing, since more than 60 years. 3D printers since the 80s. So why are we now talking about this revolution? And I think it's on one hand because accessibility, so the parts are a lot cheaper. So, and also the interfaces are a lot simpler, so it's much easier for people to have access to these machines. But I think in the last 10 years there was also a lot of new kinds of machines that are not necessarily categorized in this sort of maker movements. And those machines are maybe not even on the market yet. This is just an example of a sort of a logistics concept. It's not a concept, it's actually, it was bought by Amazon 2-3 years ago, where you have these, I don't know if you see the orange things here are moving robots, and they're bringing shelves to the people, rather than people go to the shelves to pick up the stuff. So this sort of revolutionizing the way people are working in logistics right now. And that's because of new possibilities of sensing that each machine knows where it is in space and what it should do. Another breed of these developments are flying machines. And that's a very big topic right now in research, especially in robotics research. It's not so much, I mean, you can buy them as toys and for observation tasks, but there's not so many products actually. It's not like an industrial robot that is sort of on the market for a while. And this was an exhibition project from 2011, 2012, where we collaborated with the chair of Rafael D'Andrea at ETH, who is an expert on robotic systems and especially flying machines. So we built this exhibition project in Orléans, where we had 4 quadrotors cooperating to build this 6-meter tall structure made out of 1,500 foam elements. And this was the first time that actually we showed that you can build something with these machines. And they can collaborate to do that. And yeah, it was quite performative. And it was not, from it was not an architectural installation. I mean, it was an architectural installation, but it was not a building that we built. It was in a museum context. So from this project, we started a new research project 2 years ago, where we asked the question, can we actually use these machines to build structures? So actually in architecture, there's a long history of concept of using flying machines, whether it is for transportation, as structural support, or actually to build structures themselves. But I think what's quite different now is that we can control them robotically. We can link them directly to our design environment. And we started with the idea of using, again, sort of these rigid elements, linear elements, to build space frame-like structures, that they would cooperate to build space frame-like structures. These were sort of some of the first tests we did. Of course, when you work with a flying machine, everything has to be extremely lightweight. But we realized very fast that there's big differences between a flying machine and an industrial robot. Not just the weight that you can lift, also the things you can do with it. I mean, an industrial robot has, as mentioned, 6 axes to go in every orientation and every point. But a flying robot can't do that. As soon as it starts to tilt, it sort of accelerates and moves away. So it can't hold an element at any given orientation while hovering in place. So we had to develop strategies how to deal with that. So what we do here is basically you use a vacuum gripper that holds the element at a certain angle that conceptually would be done on the ground, where you have a robot on the ground that feeds the element at a given orientation, generates a vacuum, and then locks it. And then the machine would place it at a given position, and then the vacuum would be released. These were some of the first tests we did with that. But I mean, that was one big problem we had to work with. But another one was that the machines are just inherently unstable. Even though we have quite an accurate tracking system in an indoor situation, you see that they always try to correct themselves. They're never actually super precise, like, for example, an industrial robot. So that was a big problem here. And another thing is, like, they always try to adapt to the environment, which is good, but also if they are in contact with the environment, also it comes to a lot of problems. What you see here is we try to help it a bit to find the spot, and then it starts to oscillate and to deal with the tolerances. And this is the second one. And this is, in the end, was a rather destructive proposal. So flying machines are inherently unstable. They're extremely difficult to control. They can't lift a lot. So why are we using them? Why do we even want to work with those? And what we then started with was the idea of building tensile structures with them. And I just want to quickly show some of the results of that, because it deals with the problem in a different way and I think has certain potential. What we do here is, we have a lightweight rope that is wound on a roller here, and the machine attaches it to an existing pole by flying around it. And once the friction is enough, it flies to the other side to attach it on the other side and come back to that. And this simple example already shows a little bit what the potential of these machines can be, meaning that they're not actually connected to the ground. They, like, for example, an industrial robot again, or a CNC machine, it can build structures that are a lot larger than themselves. And it doesn't really matter if these poles are 5 meters away from each other, or 20 meters or 100 meters. And it doesn't really matter whether there's a canyon in between or not. So these are sort of the things that sort of made us quite excited about. And another thing that is very particular about the flying machine, which is sort of shown here, is that it can fly through and around existing objects. Again, if you imagine any other machine that is not flying, it would collide with itself or with the structure when trying to do a maneuver like that. So since the structures we're building don't necessarily have to be built from the ground up, we have to think about how do we sequence structures like that? What kind of structures can we even build? we see here on the left-hand side is this kind of pattern. It could be, I don't think it was planned like that, but it could be built by one machine by just sequencing in the right order. So if you would first fly the green diagonals and then the blue diagonals, and then in a third iteration intertwine the whole thing with the red mark thing, you could build this with one machine by just sequencing it in the right order. With the braid on the right-hand side, that's a different story, because it can't be sequenced in individual steps. It has to happen all together. That's why we're also interested in actually having the machines cooperate in building structures. And this is just a first attempt of doing that, where we show that you can have two machines sort of dancing around each other, making a ballet in creating a knot in space, something that one machine alone couldn't do. And again, because it's basically just a tool in space with no body, they can go around each other without sort of blocking each other's operational range. Yeah, this sort of brings me to the end. I think it's important to mention that even though we're really interested in what's happening technologically, what is new and what's coming, it's not a pure technological vision here. It's just a tool that expands our current possibilities, but it allows us to link our design work with the fabrication. Thank you very much.
Great. Thank you, Amar. We have got 5 minutes for questions, so we'll take them from the floor. Please raise your hands and I'll run down to you. First one.
Hi, it's
Hi.
Professor Karen Ingham. I'm really interested, even before you showed the last colour iterations and
Yes.
other things, when they're first moving and dancing around, the movements they make are very like weaving.
Yes.
They're very loom-like. And I just wondered if you'd thought about collaborating with a weaver and look at some of the weaving and loom technologies and feeding that into what's happening here, because it could be quite an interesting and possibly informative collaboration.
Yeah. Well, it's how should I answer that? I mean, we actually showed it to people who are working with textiles as well. However, I feel like we were still so much at the beginning of this that we can't really we still have to solve the really basic things of just like flying in space, how to go through things. And I think in a second step that would be extremely interesting. I mean, I can quickly show what we're doing right now is basically we're just creating a sort of a catalog of knots that we can do and trying to just test what is possible in what orientation and what is not possible. And there's quite a lot that is also not possible with it. I mean, having, for example, the two machines hovering next to each other works very well, but as soon as if they're on top of each other, they generate wind, and then they get unstable. So there's a lot of these constraints that we still have to really define, and I think then in the second step that would be extremely interesting, yes.
Another question, please. Down here.
John McMahon from the Crafts Council, and I snuck in late, so sorry if I missed this earlier in the presentation. I was curious about, can you, or have you experimented with controlling them sort of haptically? So, you know, almost like you could use them like giant knitting needles in the sky and it would be kind of hand controlled but expressed on a giant scale, or is that something that you've looked at? Or?
It's not, I mean, we're sort of interested in sort of relating it to our design environment, which is usually on the computer. So, yeah, but from the robotics perspective, I think that's something that is quite interesting, that the interaction with humans. And I think there's actually a lot of potential in that. Especially, you can combine it also with the digital design that you create on the computer. For example, you can tell the machine to only work in certain spaces, and for example, you can tell it to only operate in a sphere motion, right? So you can't, and that's sort of something that is maybe more intuitive for people to work with. Yeah.
One more question, please. Looking round. I've got a question for you, Amar. When you showed the tools that you made for the robot arms that were scraping away,
yes.
Did anybody test them first manually before putting them on the robot? Actually, what did it feel like to make those marks? Were they aesthetically pleasing before then you put them on the robot?
Yeah, I mean, that was the basic concept, that first we try it by hand and then see how it works in the robot. But I felt, and we did that, and that's why we sort of came to the roller, and that's why I came to the scraper. But it was interesting to see that the students were more obsessed with the tool itself than actually testing it. And they were really trying to make a very nice tool, but then they didn't really test it enough, I feel like. So, yeah, but sort of that's why we came to the roller, and that's why we came to the scraper. This was just sort of evolution from the stamper to something else. Yeah.
Thank you. And maybe time for just one more question, if there is one from the floor. One right at the back there. I'm going to leave the stage, come this way. Hand up again, please. Here we go.
Hi, it's Rob Kessler, Central St Martin's. It's a general question, really. Is it possible to be aesthetically unpleasing?
I didn't get it also, sorry.
Is it possible to be aesthetically unpleasing? Maybe that was that directed at me for saying aesthetic. Sorry. Should we leave that one hanging? Yes.
Maybe
Good.
so,
Very political. Thank you, Amar Majan. Fantastic. Round of applause. That's certainly one to be discussed maybe when we leave here. So thank you, Amar, for a very forward-looking, beyond now vision of the future for what craft might hold for us. And what making, more importantly, will hold for us. So what is next for the craft sector? How are we thinking about how we innovate and drive ideas and thinking? I'd like to invite back to the stage the 3 session chairs from our 3 previous sessions, Making Materials and Tools, Daniel Charney, Zoe Lohan, and Mike Prez, to actually lead our group into battle.
Thank you very much. Have you had a good time? I can't hear you. Have you had a good time? Whoa! It's been great, isn't it? I don't think you probably expected to learn quite so much about dogs, gaskets, and flying robots. I mean, did you? Did you expect this is what was going to come? There's been some fantastic input, I think. And we're going to try and pull some things together. But it's been great. I mean, on a human level, it's been great. Just all the different diverse people coming. Martin Woolley, my old colleague, and I were talking earlier about, we've been coming to Crafts Council events off and on for nearly 25 years, you know, and you kind of see some familiar faces, and then other people kind of strangely out of context, or people that you used to teach who are now a dean somewhere. And Martin said, yes, it's like going to a very big funeral. And it's true, really. Not that we're actually burying anything. So we have about 25 minutes to try and pull together the strands of this very big funeral and to draw some conclusions from our experiences of chairing the different themes. So I think each of us are going to try and identify our 2 key takeaways or our 2 key observations before we pull you into the discussion. So Zoe, do you want to kick off?
Yeah, so, excuse me, material production. Anyway, my session was on materials, and it really struck me that actually what came out of that was this notion of the material as a maker in that respect, of the agency of stuff, and our relationship to that was something that people were now working with, in that if you can start to design material and you're acting as a maker at a certain scale of building structure, you can actually engender properties and start to make matter that is of itself new, really. And this is something that's both new within the material science, but also new to craft and making. And I think it sits really at the intersection between the two, that you're really having to apply processes of making to something that would be quite scientific. But really what you're, excuse me, what you're asking is you're asking something of a material which is related to properties. And once you start to think through properties first and ask your material to be like a certain thing, you bring out those questions of what is this stuff like, but also what do I want it to be like? And they seem to me like key questions around materials and making. And that if you can start to design that, actually you start to deal with things that we all kind of know, but you're on the parameters of knowing. So we mentioned in Mar's session, shininess came up. And we all know when something's shiny and when something's not. But what would be the scale of that shininess? And how does it go about being measured, but also how does it go about being made, and how do you go about making things more shiny? So if you come from one tradition, you could be talking, okay, we're talking polishing, but actually polishing metal, polishing wood, polishing plastics require different processes. And maybe if you build a material from the bottom up in order to embrace notions of shininess, maybe that will produce something interesting. But then that also presents a problem of language, and that to one discipline, the word strength means something very, very specific that has a formula associated with it. So the strength of a material is quantifiable, and to others, strength and stiffness and what it feels like in your hand are less quantifiable and more expressive. So there's a problem around translation, and I think that's, again, something that came out throughout a number of panels of how does knowledge get translated between them, and maybe the object is a parcel of knowledge that can help in that translation. By having a prototype, having a thing, and you pass it to someone and go, I want it a bit like this, actually you're learning through that material engagement. Excuse me. And then so the last point I wanted to raise was that of, I think it's going to be coming up commonly, that actually material, tool and process are therefore inextricably linked, and it's very difficult to isolate one from the other. And Daniel raised that at the end of his panel, but I think we've seen it continually, that the really fantastic work understands material and process and it together, hand in hand. And if you want to make something, the tool you're using and the thing you're making out of are part and parcel of each other. And that so not only is material a maker, but I think material is also a tool. And that would hand me over to your making session.
Yes, thanks so much. I think one of the key things that came out of the making session was the issue of collaboration. And that was common to all of the three panelists. And the notion of reciprocal illumination, it was something that Roger Kneebone raised as a way of looking at an approach to making, I think, that is common now across all disciplines, whether they are, if you like, conventional making craft disciplines or others. And his point also about how we value the eloquent voice of silence, that's something I think that particularly the craft community needs to explore. And tied up with this, there was something that Tony Quinn was tweeting earlier, the link between language, skill, collaboration and trust to develop and sustain one's practice and one's community of practice was something that he took away from that. And I think that, yes, there is that association between language, skill and collaboration and trust. The other theme that came out of not only that panel discussion, but many of the other things I've seen, is about discovering new value in all kinds of things, whether it's materials, whether it's seaweed, loofahs, industrial estates, and then finding that value and then mixing it into new context. Whoever here is tweeting for Benchmark tweeted something yesterday saying that, I paraphrase, the maker is a DJ, and I think that nails it. That's what makers have become. They become DJs. They mix stuff together. They find things that are, they mix age-old knowledge within new knowledge, and they create something new. And it's that skill, and it is a real profound skill of how you're a good DJ as opposed to a bad DJ, that's important. The session that I came out of this morning with Michael Eden was described as the Brian Eno of craft, which was very interesting and very appropriate in certain ways. But that got me thinking actually about something that Brian Eno said 2 weeks ago. And he said that in any creative practice, there's two types of people. There are farmers and cowboys, and you need both of them. And the point is that people will transfer from being a farmer to a cowboy and vice versa. We teach craft often as a form of farming. You know, that you have this intimate relationship with a fixed territory, and you farm that in a lengthy, protracted way. Brian Eno said that he's always preferred actually being a cowboy, going into a completely new territory, taking what knowledge you might have had about farming and trying to apply that elsewhere. And I think Michael Eden is a cowboy who used to be a farmer. I think that's another way of looking at it. So there are different forms of practices and different forms of making that seem to come out, for me anyway. Daniel.
I'm going to jump to some, because there's a lot of commonalities, but I think one thing that came out of the speaker's observation is, I think, to do with access to tools. We were talking about tools in our session. And really that is shifting and changing. And the access to the experience of using the tool rather than knowing that it exists. And how that is built and how that is happening now in terms of, I mean, there's a lot that we can learn from what happened with code and open source coding and just that ability to take parts and put them together in a different way. And these are tools. So I think that kind of links access to industrial tools that are now, again, being part of makers' arsenal. And access to other people's knowledge and collaboration through access and sharing, knowing where to find things is changing, the way we're learning. So that was, I think, one big underlying issue. In regarding to tools, the other one, I think, and that's a really interesting one, is the whole relationship of tools to instructions. That everyone talked about, and that's also what they're messing about with the instructions, whether it's the coding or the movement, and where are they getting that knowledge about the instructions? You know, we've just heard these amazing flying machines. The movement is first tried out by hand. The folding of the robots, first by hand. The stitch, first by hand. The ceramics, first by hand. It's kind of really present, and the relationship between experience and instructions, and having that knowledge when you are designing the tool, and having that help you shape, control, free up the language of the tool. So I think that was a very strong one that connects to your knowledge of materials and making. I think, after all, if we're talking about this in materials or in making or in tools, there's this whole process of getting to know it, and then the subject that kind of came up is, when does it enable you to do things you couldn't before, and when does it limit you from doing things because you are in that rigidity of that habit or of that tool under that tool. And we all know that we get used to things. And I think that's kind of what, just connecting to the whole event, make, shift, do. This whole aspect of shifting things on is something we always have to remember, that not to be constrained by the opportunities that we are exploring.
Okay, thank you very much. And now it's over to you. So I invite you, not so much for questions, but more comment and observations and what conclusions you're drawing from this event. So who would like to kick off? No pressure upon you at all. Yes.
My name's Henry Pym. I found it very, very interesting to see all these different technologies at work. As a maker, I use very little technology, actually. I just use a kiln and my hands and some very simple tools. And I have to say that I do have, initially anyway, a kind of Luddite reaction, that if I was to work in partnership with somebody else and rely on their knowledge, I personally might get swamped. And I think that's something that I have to fight. It's a very important thing to feel that, having been brought up as a sort of standalone craftsperson, that I have to continue to stand alone and not rely on the expertise of others.
Okay, thank you very much. Anybody else? Sorry.
Hi, Tim Parry-Williams. It's a small general observation. There's been lots of talk about considering the place we are, the place we've come from and where we might go. And it's just in my mind that it's a very important time, because we are, well, we'll use that phrase, we're the enlightened ones, we're aware, we're looking back, and we're trying to look forwards. and we kind of have it within our power to ensure that something that we're trying to take forward preserves or seeks to preserve what has informed it. It's also a very fragile moment because if we don't look after where we've come from, those in front of us can't possibly retrieve it. So it's just I think it's a very important time. It's this transitional moment. We need to be very aware of what we actually have the power to do with this knowledge that we're considering.
Thank you very much. Over here.
Well, one of the things I've been really struck by, particularly in today's sessions, is about technology's ability to, in some ways, replicate what we do with our hands and kind of find new ways of extending that practice. But one of the things that I don't think has necessarily been addressed yet is technology's ability to capture those haptic experiences. So what that gentleman was saying about losing those abilities if we don't kind of capture what has gone before us and getting so excited about using new technologies, that if you think about the way that a ceramicist handles clay, there's got to be a way, I think, of capturing that haptic technique and preserving it and passing it on, and I'm quite interested in what possibilities there would be for that as well.
Can I just come in on that and say how incredibly hard it is, actually? It's because I go through lots of things. A big thing in well now is like things like the digital finger, like trying to make a probe that can run its finger over something and tell you how rough it is. It's like, well, I can do that. And it's so incredibly difficult to make something that even can capture something like roughness. And as our finger is both looking at roughness, what we're also looking at is, the hardness of the stuff, the surface texture, the thermal capacity, like how cool is it? I mean, if things are colder, they often feel harder, but that might not be actually scientifically harder. And just the complexity of our senses, I suppose, and that we should really celebrate that, because we are amazing tools and amazing experts, and we spend our whole lives touching stuff. So just touch them more. Yeah.
No worries. John McMahon again. And it's been really interesting. Obviously, I would be kind of pondering from the role I have at the Crafts Council how these themes influence or intersect with, education, children, young people. There's been some really interesting. There's been a great kind of interesting presence for students in the conference for the kind of disruptive influence of the different types of skills that they're bringing into the kind of craft workplace. We've not really spoken about younger children, about the impact that the influx of a generation of digital natives is going to have on our understanding of and kind of experience of craft making. And that's something that, for a lot of us, because loads of people in this room, as well as being makers or organisations, work in educational contexts as well, and it's something that it might be very interesting for all of us to grapple with and kind of ponder upon.
Hi, I'm Julia Roundtree, Playground Collective. One thing that's struck me is obviously the very extensive talk about collaboration, and I think there's a really interesting exploration to be delved into further about the methodologies and civilities of collaboration. And I think going to the education world, there's some incredible assets in our country about inclusive practices within participatory education in theatre and in other visual arts practice. And I just think it would be great to put a spotlight on those on another occasion.
Great, thank you very much. Was there someone over here at the back?
Yeah, firstly, I just wanted to say how much I've enjoyed the day. It's been really amazing and really insightful and forward-thinking, which I think is incredibly exciting within a craft conference. But I equally coming back to the idea of kind of understanding haptics, and my own belief that it's just as important to look backwards as it is forwards. I mean, there's just one instrument, and bringing back the musical connotations to the discussion is the idea of a record player, which very simply registers texture and informs you of how that texture is. So I just kind of, I just wanted to underpin the importance of making sure that we double check history and that we haven't missed anything simultaneously as we look forward.
Can I pick up on that? I think there's a kind of habit of splitting between the past and the future, and I think we should be looking forward, backward, sideways. We should be looking. We should be up for what's going on. You know, everything's a material, everything's a technique. This separation is not, I don't feel it's healthy. We're stuck in it. And so many conferences deal with this. And continuum is a very interesting concept, but actually it's also limiting. And I think we should be looking. But it's kind of something that I think everyone knows, but we use words to define it differently when we're speaking about it. As makers look to materials, they don't look at something that's been used or not used. It's does it fit what I want? It's kind of about the purpose of what you're trying to make or express. And you know, this recycling is a great idea, but when you look for something to use, you look for the material that fits the direction that you're looking for. So it might be something from the past, and it might be a material from the future. And we need to be really, I think, just more attentive.
Thank you. We've got time probably for another 2 or 3 questions or comments.
I'm Karen Hansen. I'm really glad I came. It's been very interesting. One of the things I think we need to remember in working sustainably and working with human beings as caring people, that we remember soul. And I think that's the digital challenge. I still need to see the soul in it, and which maybe comes over time. But you know, let's use it as a way to get where we want to go, rather than be overwhelmed by it and think we have to fit in. You know, craft and actually touch is fine by itself.
I think that's what's so powerful about Dries' measuring objects, is that actually you can say, I want it to be like this, and it's a kind of interface to the CAD that if you know, I don't want to punch in the numbers and move a mouse maybe, or maybe I want to use my hands like this, and there's a lot of those kind of scanning haptic digital clay things that are actually relatively unsatisfying, but the idea of a ruler that you can then express with, I think, is really powerful. Like, these are now new tools for interfacing with these types of technologies. Could be really interesting.
Okay, Raymond.
I've got maybe three little points to make. The first one is my wife did hear about me yesterday, and she said, "Don't get the train back tonight." So I'm sort of looking for accommodation at the moment. Second thing is, this is a classic example of 300 people in a room like this. You're all looking inward. You've talked about really nice, soft things. It's great. You're not talking about the shift. You're talking about make. You're not talking about the shift. The shift meaning, where are we going? And are we going to do this individually, or are we going to do this together? So it's all so gentle. I think some of the things I've heard about in the 2 days should be highlighted in terms of what you would call real successes, things that have captured the imagination, that goes beyond the Craft Council, goes beyond the UK, it's gone out internationally. How do we get these things across, that craft and making is important for the soul, but it's important in terms of creating value, and it's about people thinking that their future is not about next week, it's about the next decade, and how are you going to make that happen? I don't have a future the next decade. I'll be clobbered on the head by then. But you have to think on that decade-long time scale. So that the shift is about understanding what it is that you consider to be important enough to work and collaborate together enough to show the genuine importance of craft and making. And it has to be shown to those people who you need to influence in the future. And if you keep on talking about what's been talked about here in the last 20 minutes, that won't get you a penny.
Thank you very much. Any other comment? Maybe picking up on Raymond's point. Anyone? I'd like to echo that, actually. I mean, craft in education is actually under attack at the moment. And that's been kind of the elephant in the room for this 2 days. And we have to recognize that, and we have to galvanize those arguments, because we believe in it, don't we? We believe in craft actually quite profoundly. And it is under assault, and we have to defend it, and we have to make its case. So we have to take things away from this 2 days and use it constructively, and yes, use it politically within institutions and organizations to make the case for craft, which unfortunately we have to keep making and making and making.
Hello, Ashley Hemingway. I'm a bit nervous about talking, so bear with me. I came here today, or for the last 2 days, because I work at a college. I currently run a foundation degree, and I've been given the go-ahead to write a new BA in craft, which I think is quite amazing for the moment, because we are hearing about all sorts of courses closing down. And it's really inspired me today, or for the last 2 days, because I wanted to come here to think about the things that students need to actually be learning about. I can't deliver everything that's been talked about in this room. I work in a small institution, but any sort of feedback that anybody could give me would be really, really useful. And I think that what I wanted to say to many people, but it's been a very busy event, so I haven't been able to, is that, we are all so passionate about craft. And one of the things that I was going to mention on the comment that was just made, we are naturally fairly quiet people. We tend to sort of put our heads down and get on with our making. And we often find it quite, well, I'm speaking for many people, I'll speak for myself in this, but the people I've met are often fairly quiet people, and they tend to find it quite difficult to stand up and shout about things. But we are all very passionate, and maybe what we need to do is get together a little bit more outside of this kind of event. Talk to people that really have no idea about craft a little bit more. And I think people like Zoe is amazing, because you are able to convey and say the things that a lot of makers find very, very difficult.
Thank you.
Not when I got a cough. Julia Lohmann. I think one thing that came out was that you can learn through your hands, that you can that language doesn't carry everything. So maybe one way of keeping craft in the curriculum, keeping the importance, is to figure out where could we actually incorporate it in other subjects. Maybe there could be a craft studio, and you go for your programming class, you go there because immediately you can see whether your code worked or not. So you can teach programming with craft, and maybe you can teach English with craft or language. Maybe this connection could be made much stronger.
Okay, thank you very much. And I think a positive note to end this part of Makeshift. Thank you, all of you, for coming along, and also for the comments that you've made. We finished this a little bit. We've still got another bit to go, so I'll hand over to Red.
And please, a big round of applause for Mike Press, for Zoe Loughlin, and for Daniel Charney for their sessions and their summary. Now, for the closing remarks, I'd like to introduce the Crafts Council's Chair of the Board, Professor Geoffrey Crossick. Geoffrey is a social historian of 19th and 20th century Britain and continental Europe. I think a very good skill if, like Geoffrey, you're a Tottenham Hotspur fan and you need to delve into the deep, distant past to relive the old glory days. Cheap. Very cheap. It's amazing what you can find on the internet. He also speaks nationally and internationally on the importance of the arts and humanities and on the 21st century creative economy. Previous roles include Vice-Chancellor of the University of London, Warden of Goldsmiths, Chief Executive of the former AHRB, Pro-Vice-Chancellor and Professor of History at the University of Essex. He's currently Director of AHRC's Cultural Value Project and Distinguished Professor of Advanced Study at University of London. Please welcome Geoffrey Crossick.
Thanks very much, Brendan. Can I, before anything else, thank you for your fantastic comparing and getting us through this event so well. Thanks very much indeed. There was a question about history, and Daniel referred to history in his closing comments. So, as a historian, let me say one thing absolutely clear, which all historians know, which is the future is absolutely clear. It's the past that we can't understand properly. And I think that's genuinely the case, and the past of craft is one of those, because we keep rewriting it, and I think we've rewritten the past of craft today, again, in really interesting ways. And without that, we couldn't really understand the kind of future we're trying to chart. I can't sum up what's happened, because actually, first of all, we've each had our own personal experiences of this extraordinary event. Also, because we've just had a great summing up by the three people who'd organised the main panels. So I just want to offer some personal reflections and obviously also some thanks. This is not the only makeshift. It's going to be a biennial event. We'll be back again in 2016 and in 2018. And in between, as I'll say in a few moments, there's going to be a continuing programme of symposia, cross-collaboration projects, all sorts of other things, building on the themes that we've had in yesterday and today. And of course, Makeshift Do is on both today and tomorrow. And those of you who've been watching on Twitter will have seen at least some great images coming from Dundee. I don't know what others were tweeting about it, but there was some great stuff coming through from what's happening in Dundee. Do download the app for Makeshift Do and take the chance to explore what the different spaces are all doing. I think this has been an absolutely extraordinary event. And I think part of it we can just see from the number of people still here at the end. The numbers have kept up right the way through, apart from those people who simply had other engagements. I think that's been remarkable. And it's because it has been, I think, extraordinarily exciting. One of the exciting things about it, one of the things that I have learnt from today, or been confirmed by today, is that just about every story that we've had in every presentation, particularly presentations that are about actual things that people have done, which is what we've had most of the time, every story has been about people talking to each other. Yes, they've been accessing ideas from other disciplines. Yes, they've been moving into other territories which they weren't familiar, but they weren't doing it in a formalistic way. They were doing it by meeting people, talking to people, and sharing ideas in that way. And that, we know, is how you move forward in the arts broadly. It's how you move forward in making. But actually, when I talk to people in science and industry, they say that's how you move forward in science and industry as well. It's absurd to think that the way in which we develop and share knowledge in our worlds is somehow totally different from what goes on in science and technology. It isn't. I think together we've, what I've noted for myself just now is we've started something very, very important. I don't think we've started it today. It's been underway. We wouldn't have had the Makeshift conference had we not known that this process was underway. But what we've done yesterday and today is turn the spotlight on this extraordinary process. And it's something where it's very important that we keep up the momentum now. Momentum with policymakers and momentum with ourselves. A word about policymakers, this sort of somewhat ambiguous group of people whom we know are for some reason hostile to us. Otherwise we wouldn't call them policymakers, we'd call them something much more constructive. We in the Crafts Council talk to policymakers a lot. The issue is not to make demands of policymakers, but to engage, everyone's making demands of them, but to engage with them, to help them understand what it is we're talking about and why it matters. One of the things that I've been really impressed with yesterday and today is that we've had virtually no moaning and whinging about the way the world treats us. That's something very unusual when people in the arts world get together. And it's a sign of our excitement that actually we've got this extraordinary positive story to tell, and we want people to understand it. It's very good indeed that Innovate UK, through the Knowledge Transfer Network, has actually backed this event, because those are amongst the people we most need to talk to. The issue is that we have to get across, and that we've really seen yesterday and today, is this is not about technology driving things forward, which is what most government policy believes, because that's what they find that easy to understand. What we've seen yesterday and today is makers and technology genuinely developing ideas together. Technology is simply part of the mix. It isn't the driver. And I was very struck this morning by Michael Eden's presentation, or his discussion, when he referred to technology as just another tool. And makers have known for thousands of years how to use tools, and technology and software and computers are just another tool like that makers have to master and use to produce the kind of products and working with materials that they've done for centuries. But policymakers, who we do need to persuade of that, and we do need to engage with them so they see the potential of this and realize that they've got to change some of the ways of thinking about the relationship between technology and innovation and art and craft and ideas. Policymakers are not what it's all about. As we've seen yesterday and today, we need to do this ourselves by getting together with each other and with others to make this happen, to build and embed new relationships. It's something for those of you who've managed to look at the Craft Education Manifesto that was in your pack, and many of you will have seen it beforehand. One of the things that's very striking about that manifesto is that we ask less of policymakers than we ask of ourselves. In that manifesto, we say what we is people in the craft community, educators, industry, business, what we will do, and then we need the support of policy makers. We don't want to simply ask them to do everything. But I think that's the approach we have to take here as well, and we're doing it anyway, because all of this is going on, all these connections are going on. But I say ourselves, we have to take control of it and maintain the momentum. What is ourselves? Well, ourselves is obviously the craft community. That's the biggest part of this event. But actually, what's I think really exciting about the event and about what the event is reporting on is how much we've broken out from that world of craft alone. It struck me this morning that actually all kinds of relationships emerge, but there's one triangle that I think I'm taking away from me from this that's a really important triangle. It's the relationship between makers, industry and manufacturers, and universities and higher education institutions. It's that group of makers, industry, and higher education institutions that has time and again emerged as an absolutely critical network, a critical triangle for what we're talking about. Links into industry and manufacturing have come up much more frequently than I thought they would in this event. They've come up time and again, not just in Fee's tours around the industrial estates of Scotland, but time and again, people's contact with industry and industry's interest in what they're wanting to talk to them about has been very striking. And the way that industry is actually intrigued by what it is that makers are asking of them. In that engagement, there has to be benefit to industry as well. And what is clear is the opportunity for showing how much industry and makers have to offer each other. That triangle is something that we in the Crafts Council want to pursue. And I think it's going to be a really important one. But I'd add a fourth element to it, and it follows on the comments we've heard from time to time in this conference, and that is education as part of that mix. It's what I felt yesterday and today, and I was pleased to hear it again just now, is that our Education Manifesto for Craft and Making, launched last week in the House of Commons, at the House of Commons, is even more important than I thought it was after yesterday and today. What we've been doing here is breaking down the silos and showing the huge potential of what happens for makers and for innovation when those silos break down. And yet what is happening in the education system increasingly, particularly in school education, is the silos are being built up even more clearly. We need to resolve the growing educational crisis for craft, for the arts generally, for craft in particular. This is now really urgent. And we must open up young people to the future that we've been imagining and describing yesterday and today. So I would encourage you to do all you can to support what's in the Crafts Council's Education Manifesto and the education issues in all sorts of other ways. Okay, what next? I mean, those are my thoughts coming out of this fantastic event. What next? The Crafts Council has all kinds of plans. There's going to be, let me just highlight them. There's a film of the conference and of Makeshift Do, which will be available on our website. As I said, we're going to deliver Makeshift as our biennial major conference, so again in 2016 and in 2018, to continue to raise the profile and recognition of the importance of craft in innovation and of craft innovation, and to stimulate debate and to forge new partnerships out of that. We want to keep this debate going. In alternate years, the years when Makeshift Conference doesn't take place, we're going to offer symposia and discussion events nationally and internationally, bringing makers together with other sectors to showcase projects, demonstrate, debate, and so on. And these discussion events will be complemented by practical makers labs to explore and develop new models of practice. We need your help with all of this, but you will hear a lot more about it as time passes. We'll continue to deliver Portfolio, which is part of our talent development and innovation program, supporting collaboration between makers and other sectors. And those other sectors conventionally range from health, engineering, digital technology, architecture, manufacturing, and much more. You've heard about parallel practices during this event, the current collaboration that we have with the Cultural Institute at King's, which is supporting makers and medical academics residencies. You've heard about them here. They complete their work in the new year, and there will be in March a celebration and showcase event for parallel practices. But given how successful the project seems so far, we're very keen with the Cultural Institute at King's to get further phases of parallel practices and its equivalent in the future. Makeshift Do, our mini festival of new making, which we're delivering across the country at the moment with 21 partner venues to coincide with the conference. We're going to continue that on an annual basis, and because we want to make sure that the wider general public have the opportunity not just to discover and experience the fascination and joy of making as such, but making when you think about it in innovative and exciting and personal ways. And finally, before I get to the thanks, obviously we can't do any of the things I've just been talking about without partners. We'll continue to work with the Knowledge Transfer Network and Innovate UK to research and promote models of good practice in this area. But we also want to seek out new commercial partnerships and academic partnerships to research craft innovation. And if anyone here would like to talk to us about that, please do raise it with the Crafts Council staff present or contact us afterwards. That relationship I've pointed to between makers and industry and higher education and the wider education agenda is something that we really need to pull together, and we'll pull it together with your help and your ideas. Finally, my thanks. A very big thanks, as ever, to Arts Council England, our primary funder, without whom all the fantastic work that the Crafts Council does could not happen. Thanks to our conference supporters, the Knowledge Transfer Network, the Royal Commission for the Exhibition of 1851, who funded the app for Makeshift Do, and given for those of you who subscribe to Craft Magazine, actually, those of you who have seen the 50 great moments in craft that you had in an extract from it in your pack, will have seen that I suggested the 1851 exhibition as the great moment in the history of craft. It's always presented as the great moment in the history of industry. It isn't. It's a great moment in the history of craft. So it's good that the Royal Commission of the Exhibition of 1851 supported this conference. Terence Conran and Peter Prescott of the Boundary Restaurant, where many of us ate yesterday evening. Ravensbourne, the fantastic location, especially to Claire Selby and Laura Lilliprune. And our very warm thanks to G.F. Smith, the providers of specialist papers for the creative world, for their extended and committed support to this event. We also want to thank our Makeshift Do partners, obviously. Zoe Laughlin at the Institute of Making, Nat Hunter at the RSA, and Irina Papamitridou of the digital program at the V&A. I'd like to thank our team that was so involved in producing this event. Jane Saunders for her impeccable production, Scott Williams from A2 Design for the fantastic visual identity of Makeshift, to our hosts, Anthony Story and Brendan Walker, Taskit Priyanu, our photographer, the live streaming team at Ravensbourne, and to all the speakers and presenters, above all the speakers and presenters over the last 2 days, who shared their experience, their knowledge and their expertise so generously and with a fantastic atmosphere. And last of all, let me thank our team at the Crafts Council. This has been a fantastic team effort, and you can imagine how long this has been in the planning to make it so successful. I've no time to acknowledge everyone, but I'd especially like to thank John McMahon, the Head of Learning and Talent Development, and Chris Webb, the Learning Manager, for their work on Makeshift Do. Annie Warburton, our wonderful Director of Creative Programs, who's provided leadership and inspiration for this conference. And above all, Karen Gaskell, Curator and Creative Producer, who's worked really hard to pull together such a rich, engaging, and interesting conference. But above all, thanks to all of you who've contributed and participated. We really look forward to your future involvement as we take our innovation program forward. Thanks very much.
Pick up your coats and go home, but carry on with Makeshift Do. Goodbye.